Hi everyone, so in this video we are going to start studying about standing wave patterns of EM wave. So firstly we will see what do we mean by standing wave, how these are generated, what is the actual meaning of that, and then we will study about EM wave. Before that we need to see a basic mathematics problem that you need to find the maximum and minimum value of the given complex number. Also you need to tell me the value of theta at which maximum and minimum values are occurring. So that mathematics problem you need to see. Now before starting the lecture, I will tell you in this lecture discussion is very important. So you need to have the patience. In the previous video when we were studying about EM wave reflection and transmission, their discussion was not important. We just developed two formula. With the help of these two formula, we solved all the problem. So their problem solving was important. But in this particular lecture, discussion is very important. If you do not listen to discussion, if you directly jump onto the problem, you are not going to understand anything. So first we need to see the discussion that what is the actual meaning of standing wave and how these waves are generated. Okay. So first let's start with the first one. You need to find the maximum and minimum value of these numbers. So let's take, this is the first number which is n1. I am telling 1 plus e to the power 1 plus 5 e to the power j theta. So I need to find the maximum value of this. So how do I get the magnitude of this particular number? How do I get the magnitude? So n1 is equals to 1 plus 5 cos theta plus j sin theta. E to the power j theta can be broken into cos theta plus j sin theta. So how can I write it down now? One plus 5 cos theta plus j 5 sin theta. Now if I need the magnitude of n1, how do I get that? 1 plus 5 cos theta whole square. Basically a plus iota b. What is the magnitude of this? Under root a square plus b square. So under root a square plus b square. This is your a, this is your b. So this is what we are doing. Right. So what I am getting? I am not, as of now I am just calculating the magnitude. I am not even talking about maximum or minimum value. I am just calculating the magnitude. So what you are getting? 1 plus 25 cos square theta plus tan cos theta plus 25 sin square theta. What do I see here? Cos square theta plus sin square theta is 1. So can I write it down in this manner? That it is 26 plus tan cos theta. So this is the magnitude of n1 you are getting. This is just the magnitude, not minimum or maximum value. Now minimum and maximum will be defined by this cos theta, because cos theta can vary from -1 to +1. If you remember the graph of cos theta, what is the graph of cos theta? Cos theta can vary from -1 to, 1 to -1. In that manner it will keep on going. This value occurs at 0, this value occurs at 2 pi, this value occurs at pi, and again -1 occurs at 3 pi, right? This is the graph of cos. Now if I need it to be maximum, if I need maxima, okay, if I need maxima, that means cos theta has to be 1. If cos theta is 1, then what it will become? What I am calculating? Maxima. If cos theta is 1, so what do I get? 6, because it would be 26 plus 10. Are you getting this point? What you will say that, sir, under root 36, this is under root 36. So it can be plus minus 6. Why you are taking 6? Because I need maximum value. That's why I am taking 6. And cos theta is equals to 1. What you are getting? Cos theta is equals to 1. So when it can be 1? At 0, at 2 pi, at 4 pi, at 6 pi. So it can be 1 at 0, 2 pi, 4 pi, in this manner. Okay. So can I write it down this as 2n pi? Say yes or no? Right, I can write it down as 2n pi, because if you put n equals to 0, 1, 2, any value you can take. So n is varying from any value you can take 1, 2, 3 in this manner. We will make a very good conclusion out of it. That's why we are studying it. Okay. So do not feel that, sir, why we are studying mathematics, because we need to take very good conclusion. It will save a lot of time in the derivation. Okay. You will not waste your time in the derivation if you know the conclusion. And for minima, what do I need to do? Cos theta is equals to -1. So minima, if I need to calculate, what that would be? 26 minus 10. It would be under root 16. So it can give me plus -4. Which value I will pick? -4. Why is that so? because I need the minimum value. So what is the minimum value I am getting? Minus 4. Okay, this was the maximum value you were getting. Maximum value, minimum value when it is occurring at theta equals to 2n pi. Now when it is occurring at cos theta equals to minus 1, that means what could be my theta value? Pi, 3 pi, 5 pi, 7 pi, in that manner. So pi, 3 pi, 5 pi, in that manner. So what will be the theta value? Theta value could be 2n plus 1 into pi. Say yes or no. Right? If you put n equals to 0, what you are getting? Pi. If you put n equals to 1, what you are getting? 3 pi. If you put n equals to 2, you are getting 5 pi. So n value could be from 0, 1, 2 and so on. Now what is the conclusion you are making? Let's see this number again. What was the number? Let's see this number again. Number was 1 plus 5 e to the power j theta. The number was, what is the conclusion? 1 plus 5 e to the power j theta. Now e to the power j theta can take values from 1 to minus 1. Is that clear to you? If you remember e to the power j theta graph, it was a circle. So from 1 to minus 1 it can take any value, right? Now when your theta is equals to, 0 degree or 2 pi degree or 4 pi, I should not say degree, it is radian. So 0, 2 pi, 4 pi, 6 pi, in that manner if it is, or you can say 2n pi. So at that time, what is the value of e to the power j theta? E to the power j theta. E to the power j theta is cos theta plus j sin theta. So cos 2 pi plus j sin 2 pi. What is cos 2 pi? Cos 2 pi is 1. Sin 2 pi is 0. Theta equals to 2 pi I am putting. I could put 0 as well. I could put 4 pi as well. I could put anything. I am putting 2n pi. So cos 2n pi, 0, 2 pi, 4 pi, it will be always 1 and this will be 0. So e to the power j theta is 1. That is the maximum value it can give you. At what value? At 2n pi. So whenever you see this expression, 1 plus anything, 1 plus e naught, if you see 1 plus e naught e to the power j theta, and if I ask you when will you get maxima, when you will get the maximum value, what you will say? That sir, this should be 2n pi. Because I know that sir, at 2 pi it will give me 1. 1 plus 5 is equals to 6. Okay. So when theta is equals to this, then e to the power j theta is equals to 1. And you will get the maxima. What you will get? Maxima. 1 plus 5, that is equals to 6. We were getting the same thing? Yes. Now, if I need minima, so if my theta is equals to pi, 3 pi, 5 pi and so on, or you can say 2n plus 1 pi, then what will happen? What is your e to the power j theta? Again you write down cos theta plus j sin theta. If I put pi, cos pi plus j sin pi, what is sin pi? 0. If you remember the graph of sine, pi, 2 pi, 3 pi, all are 0 only. But what is cos pi? Cos pi is minus 1. So what you are getting? E to the power j theta is equals to minus 1. So here, what will be the value of e to the power j theta? E to the power j theta will be equals to minus 1. So what value you will get? N1 minimum I will get 1 plus 5 into minus 1. So what you are getting? Minus 4. So here I am getting the minimum value. So now are you able to make any conclusion? Whenever you see this expression, whenever you see anything like that sir 1 plus or forget about 1, it is written as a plus b e to the power j theta, and I ask you when will be the maximum value occurring, what you will say? That sir theta equals to 2n pi. Are you going to mug it up? No. What you will think, sir, theta equals to 2n pi, that means 0 degree angle can also be there. At 0 degree e to the power j 0 degree, that would be 1 only. So a plus b, that is the maximum value we are getting. And if I ask you, bro, tell me when will you get a minimum value? So what you will say? That sir, a plus b e to the power j theta, that means minimum could be minus 1, and minus 1 when it becomes, when cos become minus 1, cos become minus 1 at pi. So pi, 3 pi, 5 pi. So that means 2n plus 1 pi. So you are not going to mug up anything, just this conclusion you need to write down. So now I will write down this conclusion. What is the conclusion we are getting? That if a number is a plus b j theta, so maxima and minima, considering b is positive, positive integer is not necessary. What should I write? Yeah, positive real number. Positive, I am considering b is positive real number. Okay, so if I write down maxima, so when I will get maxima? What do you think? How will you think that, sir? Okay, theta is equals to 2n pi, because at 0 it will be 1, e to the power j theta will be equals to 1. So theta equals to 2n pi. And what will be the maximum value? Maximum value will be a plus b. This is also important, and when do you get maximum? That is also important. And when you will get minima? That, sir, at this value will get minima, because at cos pi will be minus 1. So pi, 3 pi, 5 pi, those are the values which I need to take. And what will be the minimum value? That will be a minus b. Okay. Now let's see the second question. What was the second question? 1 minus 5 e to the power j theta. Right? 1 minus 5 e to the power j theta. Now take your time and think and tell me when will you get maximum and when will you get minimum. When will you get maxima and when will you get minima? Take your time and think about it. Pause the video, think about it. Write down the value of theta. At what value you will get maxima, at what value you will get minima. 1 minus 5 e to the power j theta. So if j theta is e to the power j theta is minus 1, then what I will get? 6. If e to the power j theta is minus 1, then I will get 1 minus 5 minus 1. So 1 plus 5, I will get 6. So now I need e to the power j theta equals to minus 1 for my maxima. Basically, for maxima, e to the power j theta should be equals to minus 1. And when it will be minus 1? When theta is equals to 2n plus 1 into pi. Is that clear to you? For maxima, now theta value has changed. Previously it was 2n pi. That's why I am saying do not mug up the final result. Don't mug up. Think. I need this value to be minus 1. If I need this value to be minus 1, that means theta has to be 2n plus 1 pi. Why I need this to be minus 1? Because 1 plus 5 will give me 6. So this is the value of theta, and what is the maxima I am getting? And 2 it is. So maxima I will get is 1 plus 5, that would be 6. And when I will get minima? Minima means this I need to be 1. So if I need minima, that means I need e to the power j theta equals to 1. Because if this is 1, then 1 minus 5 would be equals to minus 4. So e to the power j theta should be equals to 1. So that means when it will be 1. So you will think that, sir, cos 0 is 1. That means 0, 2 pi, 4 pi. So 2n pi. And what will be the minimum value? That would be minus 4. You can solve this particular expression. You can solve this particular expression by this mathematics as well. You do this mathematics, you will get the same result. But every time in the examination, we cannot do this mathematics. So what is the conclusion we have made is that we will see the expression and then we will think about e to the power j theta. Whether you need it 1 or whether you will need it minus 1. So you see the expression, then think about it. 1 minus 5 e to the power j theta, that means for maxima I need e to the power j theta equals to minus 1, and for minima I would need e to the power j theta equals to plus 1. So that's why I am getting these conditions. E to the power j theta equals to minus 1, then you will think about theta, that e to the power j theta is minus 1. So how will I get theta? Minus 1, that means cos 0 is 1. So 0, 2 pi, 4 pi. So that means theta equals to, okay, sorry, minus 1 I need. Sorry, e to the power j theta minus 1 I need. So cos pi is minus 1. Cos pi is minus 1. So pi, 2 pi, 3 pi, 5 pi. So 2n plus 1 into pi. And if I need plus 1, then I will think that, sir, cos 0 is 1. So 0, 2 pi, 4 pi. In that manner I will write it down. So is that clear to you? Is that conclusion clear? Okay. Now let's start studying about standing wave. This conclusion should be clear to you. This whole discussion should be clear to you. This was simple mathematics. There was no concept of EM wave. Let's start studying about standing wave. So now we are not getting into EM wave. Now, just it is also a mathematics problem. Okay, this is also maths only. I am asking question on maths only. I am not getting into EM wave. We will get into EM wave after 60 minutes. We will discuss a general expression now. How did we study traveling wave? When we started studying about traveling wave means it will be traveling in plus z direction. So how did we study? We first took this expression. Then at different time instant, we drew this waveform. What do I mean by different time instant? that at t equals to 0 I drew the waveform, at t equals to pi by 4, sorry, at t equals to t by 4, at t equals to t by 2, at t equals to 3t by 2, at t equals to t, on all these instant I drew the waveform, right? So this is the first question they are asking. This waveform is given, this particular expression is given now. This particular expression is given. At different time instant, you need to tell me the graph of ex z t versus z. That means first I will take t equals to 0. Okay. If I take t equals to 0, what do I get? T equals to 0 if you put here, E naught sine minus beta z ax cap, and if you put t equals to 0 here, what do we get? E naught sine beta z ax cap. So this minus sign goes outward, sine minus theta is minus sine theta. Now minus E naught sine beta z ax cap plus E naught sine beta z ax cap. What do we get? 0. If I put t equals to t by 4, what do I get? Ex z t by 4. So E naught sine, what is omega? 2 pi by t. 2 pi by t into t by 4 minus beta z ax cap plus E naught sine, same thing here, 2 pi by t into t by 4 minus beta z ax cap. So you can solve this on your own. T to t gets cancelled. 2 pi by 4, that would be pi by 2. So this would become pi by 2. This would become pi by 2. Same goes here. This would also become pi by 2. Okay. So sine pi by 2 minus theta, what that would be? Cos theta. So here it is plus, sorry, here it is plus. So it is E naught cos beta z ax cap. And what is sine pi by 2 plus theta? In second quadrant. In second quadrant, sine is positive. All student. So in second quadrant, sine is positive. So sine is positive. That means E naught cos beta z again. So what you are getting? 2 E naught cos beta z ax cap. That means if you click the picture at t by 4, this is the expression you will be seeing. If you click the picture at t equals to 0, this is the expression you will see. Similarly, I need to see more expressions. So now at t equals to t by 2, if I see the waveform, what do I get? What will be your omega t at t equals to t by 2? Omega t, that would be 2 pi by t into t by 2. So that would be pi. So omega t will be pi at t equals to t by 2. At t equals to t by 2, it would be pi. So E naught sine pi minus E naught sine pi minus beta z ax cap plus E naught sine pi plus beta z ax cap. What is sine pi plus sine pi minus theta? That is second quadrant. So it would be positive. So E naught sine beta z. These we have already seen in the basics. In the first lecture of vector algebra, we saw all these things, right? How to write down these expression, pi plus theta. So pi plus theta will be in third quadrant. Third quadrant sine is negative. So E naught sine beta z. You will make a very interesting conclusion and you will feel very, very good. So just have the patience. What you are getting? At t by 2, you are getting again 0. A very interesting conclusion will come and you will understand the meaning of standing wave. I am pretty sure you must have studied it in your 12th class as well, in JEE as well. But at that time, you did not understand the meaning of standing wave. Now you are going to understand it. And here it was becoming 0 only. Okay. So 0, then 2 E naught cos beta z, then again 0. Then let's check at t equals to t by 2, 3t by 4. So what will be the value of omega t? 3t by 4 into, sorry, 2 pi by t into 3t by 4. So that would be 3 pi by 2. So let's write it down very quickly. 3t by 4. So E naught 3 pi by 2 minus beta z. That means third quadrant, it would be negative. So, and since it is 3 pi by 2, that means it is 270. Since it is 270, then sign will change into cos. So cos beta z, but answer will be negative. So minus cos beta z ax cap. And what about this guy? Sin 3 pi by 2 plus beta z. So in fourth quadrant, sign is again negative, and since it is 3 pi by 2, so it will be again negative answer and it will be converted into cos. So minus E naught cos beta z Ex cap. So what will be the answer? Minus 2 E naught cos beta z Ex cap. So this is the answer you are getting at 3t/4. We are just clicking the picture. First we clicked the picture at t equals to 0. Then we clicked the picture at t/4. Then t/2. Then 3t/4. Now we will click the picture at t. At time t equals to t. So what will be the value of omega t? That would be 2 pi by t into t. That would be 2 pi only. So what do you think what you are going to get? What you are going to get? 2 pi minus beta z. That means fourth quadrant, sign would be negative, and 2 pi plus beta z, that means first quadrant, sign would be positive. Here it is negative, here it is positive. Both will cancel out, you will get 0. Very basic trigonometry it is, so we will get 0. Now, what did we do? At t equals to 0, we will get this waveform. At t equals to t/4, we will get this waveform. At t equals to t/2, we will get this waveform. At t equals to 3t/4, we will get this waveform, and at t equals to t, we will get this waveform. Let's draw all these waveforms. We have drawn it already. So this was 0, right? What this was? 2 E naught cos beta z. 2 E naught cos beta z. What this was? Again 0. What this was? Minus 2 E naught cos beta z. And what this was? Again 0. So beta z, that means beta is 2 pi by lambda. So at lambda by 4, that means at pi by 2, cos pi by 2 is 0. So this will be lambda by 4, this will be 3 lambda by 4, this will be 5 lambda by 4. What this will be? What this will be? This will be lambda by 2. Because at lambda by 2 you will get minus 1. 2 pi by lambda into lambda by 2. That will be cos pi. Cos pi is minus 1. So you know how to draw the graph. These graphs you have drawn. So what do you see here? When we studied that traveling wave, what did we do? We saw the graph, we made these graph only. Then we saw where the points is moving, where the peak is moving. Then we got to know that peak is moving in positive z direction. That's why we said that it is traveling in positive z direction, like this. Where has the simulation gone? Okay, I will add the simulation. Do not worry about that. Okay, I will add the simulation. So we got to know that it was traveling in positive z direction when we were studying traveling wave. Now what is happening here? You see this point. First this point was here. Then at t/4 this point goes upward. It became here. Then at t equals to t/2 it again went downward. Then at t equals to 3t/4 it again went more down, and then again it went up. What is happening is that this point was here, then it goes up, then it again comes to 0, then it goes down, then again comes to 0. Is that clear to you? This point was here, goes up, comes down, then goes down, then again goes up. So this point is dancing. Are you getting this point? This node is dancing up, down, up, down, up, down. What about this guy? Here it is 0, 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 always at 0. What about this guy? 0. It was at 0. Let's draw that. Let's see where this point is going. Okay, it was at 0, then it went down, then it went down, then again it came to 0, then again it came to 0, then it went up, then it went up, then again it came to 0. So what is happening? It is again, this point is also dancing. What about this node? Again let's see this node. First here, then went down, then again came to 0, then went up, then again came down. Down, up, down, 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 up. So this node is also dancing. Same, what about this node? 0, 0, 0, 0, always at 0. So this node is constant at 0. Is that clear to you? This node is dancing, this node is constant at 0. This node is dancing, this node is constant at 0. This node is dancing, this node is constant at 0. This node is also dancing from 0 to up, then 0, then down, then again 0. So let me show you how it will look like with respect to time. This is a picture at t equals to 0, this is the picture at t equals to t/4, this is the picture at t equals to t/2, this is the picture at t equals to 3t/4, and this is the picture at t equals to t. Now, if I just click this picture and I put that time button, then how it will dance? Let me show you the animation. Okay. Yeah, so let's see the animation. These animations I have got from O Physics. Okay, these animation I have got from O Physics, so credit goes to them. So this was our traveling wave. So this was a picture at certain time instant, and if I make it go, then it will travel like this, right? This wave will start traveling. So this was our traveling wave. What do I mean by standing wave? So what did I say? These nodes will keep on dancing. Basically, now this node is at peak. This node is at peak, but now this node will keep on dancing. This node will keep on dancing, but look at this node. Just keep your eyes at this node. This node will be at 0 only. This will not dance. Okay, let me start the simulation now. Let me start the animation. So just keep your eyes at this node. This node is not dancing. But now keep your eyes at this node. What is happening at this node is that this node will dance. From here to here it will go. Let's see it again. Dancing up, down, up, down, up, down. Now keep your eyes at this particular node. Keep your eyes at this particular node. This node is also dancing. Okay, again, let's see it. Start up, down, up, down, up, down. But this is at 0. What about this node? This node will always be at 0 as well. This node will not dance. Okay, let's see it. 0, 0, 0, 0, always at 0. So that's why it is known as standing wave. It feels like that this wave is standing only. This wave is not moving. This is standing wave and this is traveling wave. And how did we get the standing wave? We superimposed a forward traveling wave and a backward traveling wave. What was happening is that this was traveling in positive z direction and this was traveling in negative z direction. So one was traveling in positive z direction, one was traveling in negative z direction. Both goes superimposed, and once both got superimposed, it felt like that they are dancing at one particular node. One node is fixed, other node is dancing, another node is fixed, other node is dancing, dancing, fix, dancing, fix, dancing, fix, and this is this kind of waveform you got. And this you must have studied when we studied the string theory in 12th class. Have you done this experiment that you get one of your friends and you hold the string from here and the other guy is holding the string from there. Now what you do, you give a pulse. You give a pulse, then what will happen? That pulse will, what I am saying is that here your friend is standing, here you are standing. You give a pulse in the string. So what will happen is that this pulse will start traveling. This pulse will start traveling and then it will come back. Now if you keep on giving the pulses, what will happen? It will feel like that the string is dancing. If you keep on giving the pulses, then this kind of waveform you will get. Like you will see that the string is dancing like this. Have you done this experiment? Other guy is holding it, I am also holding it, and now if I give a pulse and if I keep on giving the pulse like this, then it will feel like that the string is dancing. So it will dance like this, in this manner. So this is known as standing wave pattern, and this is known as standing wave. And how this wave was generated, that there was a forward traveling wave and there is a backward traveling wave, and both goes superimposed and made the standing wave pattern. Is that clear to you? And are you able to understand why we are studying it? Because in our EM wave, what did we do? There was a boundary, medium 2, medium 1. One wave will come, some part will be transmitted, but some part will be reflected as well. And both part can be combined and will make a standing wave. Is that clear to you or not? At this side of medium 1, wave will go and it will be reflected back as well. Some part will be transmitted, but some part will be reflected back as well. So both combined will make a standing wave. That's why we are studying it. Again, we are not going into EM wave, but I am telling you why we are studying it. So we have answered the first question. We have understood what do I mean by standing wave and how does it look. We have understood this particular concept. Is that clear? Right? Now we are going to show that it is a standing wave and draw its pattern. We need to see what is the location of minima and maxima. So these were our graph, right? Now tell me one thing. This node was always at 0, right? This node was dancing. This was at peak sometime, and this was at lowest value. This node was also dancing. Here it is at lowest value, then it is at highest value. So what do you think, what you will call as maxima? You will say that, sir, certainly this is maxima, there is no doubt about that this is having the maximum value. Will you call this minima? Can I call this as minima? That, sir, this is maxima and this should be your minima. No. Why is that so? Because this node at lambda by 2, sometimes it is going at maxima as well. No? What I mean to say is that this is maxima. So certainly, always it will not be staying at maxima. It can take the minimum value as well. Are you getting this point? Here it is having the minimum value, but it can take the maximum value as well. So this point is also known as maxima only. So when we draw the standing wave pattern, what do we do? We take the mode, basically this graph, this particular graph, which is less than 0. sometimes it will be greater than 0 as well. You can see in the simulation as well that now it is less than 0. Now this particular graph is less than 0. And once I click on the time button, this will be greater than 0 as well. At this time it is greater than 0 as well. So sometimes it will be greater than 0, sometimes it is less than 0. So always we take the mode. But one thing I know which is fixed, what is that? This node will always be at 0. No one can stop it. So I will call this point as minima. Is that clear to you or not? That this is the least value it can get and it will always stay there at 0 only. So this is known as minima, and this point is also maxima, this point is also maxima. So when we draw the standing wave pattern, what we do, we always take the mode. Basically we will take the mode like this. This is negative, I will take the mode like this. I will take the mode like this. So this is not the exact pattern, but this is how we draw the standing wave pattern. How do we draw the standing wave pattern? So at t equals to 0, you are having a maxima, right? Sorry, not t equals to 0, at z equals to 0. At z equals to 0, you are having a maxima. So you will draw a maxima. Then at z equals to lambda by 4, you are always having a minima, and minima value is 0. So you are always having a minima. Now after that you will say that, sir, this graph is going down, this graph is going up. So which graph I will take? Always the graph which is going up only. Basically this graph is going down, but this will go up as well, no? So always I will take the magnitude, I will take the mode. So what will be the mode of this graph? Simply like this, right? So I will take the mode. I will take the mode. This was your lambda by 4. This is your again maxima. This is occurring at lambda by 2. This point is occurring at lambda by 2. You can see it. So this point is your lambda by 2. Then again it is going down. Again it is going down. This is your 3 lambda by 4. At 3 lambda by 4, again you are 0. This is the value. At 3 lambda by 4, again you are 0. Then again it goes up, again it goes down. So this is how you draw a standing wave pattern. This is how you keep on drawing a standing wave pattern. So this is a very important concept which is very typical for a lot of students. You ask any of your friend who has studied this standing wave pattern and ask him whether it was an easy concept or typical concept. He will say it was very typical, but we will understand it very carefully. I will tell you a problem solving technique as well, that how to solve the problem. So in the examination you will not have to do this analysis. In the examination we cannot do this analysis. This is just to understand the concept. How we will solve the problem, that is the different thing. So that we are going to see. Do not worry about that. This will be lambda. And what about this? This will be 5 lambda by 4. And again it is becoming 0 at 5 lambda by 4. So this is how we draw a standing wave pattern. So what was this peak value? That is 2 E naught. And what is this minimum value? That is 0. Okay. Now what is the location of maxima? What is the location of maxima? 0, lambda by 2, then lambda, then again it will come at 3 lambda by 2, then again it will keep on going like that. So can I write it down as n lambda by 2? If you put n equals to 0, 0. If you put n equals to 1, lambda by 2. If you put n equals to 2, lambda. If you put n equals to 3, 3 lambda by 2. And what is the location of minima? What is the location of minima? Minima location is lambda by 4, 3 lambda by 4, 5 lambda by 4. In that manner, 2n plus 1 lambda by 4. If I put n equals to 0, lambda by 4. If I put n equals to 1, 3 lambda by 4. If I put n equals to 2, 5 lambda by 4. Is that clear? So this is the location of maxima, this is the location of minima. So we have answered the second question, that show that it is a standing wave and draw its pattern. So this is known as standing wave pattern. Okay, standing wave pattern. So this is how we draw it. Are you able to understand the point? Now in some textbook you will find, or some educator also teach in this manner, that this is how they draw the standing wave pattern. Like here they will make a curve. You see a curve, and how I have drawn? I have drawn like this. What do you think, which one is correct? How there can be curve? What is the graph of sine omega t? What is the graph of sine omega t? This is the graph of sine omega t. This is your sine omega t. Okay, this could be one of the confusion. That's why I am addressing it here. What is the graph of mode of sine omega t? What is the graph of mode of sine omega t? The graph of mode of sine omega t is like this, right? It is not like this. It is not like this. Mode of sine omega t is like this, because I am just taking the magnitude of this upward. Just taking the magnitude of this upward. So this is how you draw the graph, not this is how you draw the graph. So here what I am doing, I am taking the magnitude of this lobe. this lobe is being taken as a magnitude. So certainly there will be some discontinuity, right? At this point it is not differentiable. I cannot make it like this. Like I cannot make it continuous. No. Are you getting this point? So it has to be like this. It is actually continuous only. I would say this is not differentiable at this point. Like it is very simple point. No one is going to ask you in the examination. But this is how you will draw the pattern. Not this is how you will draw the pattern. This is not correct. Why it is not correct? Because when we draw the standing wave pattern, what do? We take the magnitude of the negative lobe. So this is my negative lobe. Which magnitude I am taking? So if I am taking the magnitude, that means I am putting the mode. And if I put the mode value, then how it goes smooth? It cannot go smooth. It has to rise up, right? So that was the point. Like in textbook also it is shown by this particular graph. In textbook as well it is shown by this graph, but that is not correct, right? This is how it should be shown. In Chang you will find it is drawn like this only. Okay, which book I am talking about? In Chang. And the same concept will be used in transmission line, and that is the most typical concept of transmission line. I am telling you, like 9 out of 10 students will tell you that it is the most typical concept. Now we are understanding it here in a very good manner. So that thing we have understood. Now we will address one important point, that is known as standing wave ratio. Standing wave ratio. What do I mean by standing wave ratio? So when you draw this pattern, so whatever the maximum value is divided by the minimum value. Basically it is maxima divided by minima. So that is known as standing wave ratio. What it is coming out to be? Infinity. 2E0 divided by 0 is equals to infinity. So this is known as standing wave ratio. Now in the examination you cannot do all these analysis, right? So how would you solve the problem in the examination? If this expression is coming and they ask you all these things, like what is the location of maxima, what is the location of minima, what is the standing wave ratio, and draw its pattern, then how would you solve? Will you make at t equals to 0, at t equals to t by 2, then this, then you take the mode? Will you do all these things? Then you understand it is a standing wave? No. So how you will solve in the examination? So what is the expression of electric field given? I should not say it is electric field, it is simple vector field. Forget about electric field. It is a simple vector field that is given as E0 sin omega t minus beta z. So how will I solve? So that I am telling now. E0 sin omega t minus beta z Ax cap plus E0 sin omega t plus beta z Ax cap. Now what is the best tool you have studied in EM wave? When we started studying Maxwell equation, which is the best tool we studied in the third lecture? Phasors. So what I am gonna put? I am gonna take the phasor of this. What I am gonna do? I am gonna take the phasor representation of this particular waveform. So what I will get? E0 e to the power minus j beta z Ax cap plus E0 e to the power j beta z Ax cap. So let me write it down again here. What I am taking the phasor. So why I am writing like this? This was actually a vector. So I am taking only the phasor part now. So ES I am getting E0 e to the power minus j beta z Ax cap plus E0 e to the power j beta z Ax cap. Is that correct? Now my target will always be that this is the direction. So forget about the direction. Direction I will take last. Now my target would be to make something 1 plus something. In that manner I need to do. So what I can do? I can take this complete part as common. E0 e to the power minus j beta z Ax cap 1 plus e to the power 2 beta z you will be left with. Is that clear to you? What did I do? I took this complete part as common. E to the power E0 e to the power minus j beta z Ax cap. So what I will be left with? 1. And what I will be left with here? E to the power 2 beta z. How I got e to the power 2 beta z? Basically it is E0 e to the power beta z Ax cap. And what I am dividing with? E0 e to the power minus j beta z Ax cap. So Ax cap get cancelled, E0 get cancelled. This goes upward, so it becomes e to the power 2 beta z. Is that easy for you? Right? Now what do I need to calculate? I need to calculate maxima and minima. So what I am going to do? First I am going to take the magnitude of this. So if I take the magnitude, what you are going to get? Now tell me one thing. A into B is there. A into B is there, and I need to take the magnitude of that. So can I do in this manner? Magnitude of A into magnitude of B. Basically 4 into minus 3. you need to take the magnitude. So what will be the answer? 12. Can I write it down in this manner? Mod of 4 into mod of 3. What it will be? 4 into 3. That will be 12 only. Right? So in the same manner I can do. So mod of this E naught e to the power minus j beta z Ax cap, and then mod of this. So what you are getting? Your mode of Es is, here it is E naught and here it is 1 plus e to the power 2 beta z. Now from here you need to calculate maxima and minima. Now tell me one thing, will you be able to tell me? Yes. Why will you be able to tell me? Because we spent 20 minutes on this particular expression, which was 1 plus 5 e to the power j theta. So the same kind of pattern you are getting here. So whenever I teach any mathematics, like till now you must be comfortable with my teaching style, you must have understood that why do I spend time on mathematics. This is the reason. Now here if I tell you that take mode of this, take a square plus b square plus 2ab, all those things if you do, then it would become a very complex expression and you will feel like that sir, this is a very typical topic. But now you know one thing. What do you know? That sir, certainly for maxima, what do I need to do? So for maxima, what I am going to do is that I am going to put 2 beta z. What is this? 1 plus e to the power j 2 beta z. So this should be equals to 2 n pi for maxima, because I need this value equals to 1. What I will say is that sir, for maxima I need this value equals to 1, and if I need this value equals to 1, or better I should write e to the power j 2 beta z. So sir, if I need this value equals to 1, that means 2 beta z should be equals to what? 2 n pi. Okay, 2 beta z should be equals to 2 n pi. Why it should be equals to 2 n pi? Because cos 0 is 1, 0, 2 pi, 4 pi. So it should be equals to 2 n pi. Now what do I know? What is beta? Beta is 2 pi by lambda into z is equals to 2 n pi. So pi and pi get cancelled, 2 and 2 get cancelled. What I am getting? Z equals to n lambda by 2. So this is your maxima location. Is that clear to you? So if you put z equals to 0, if you put z equals to 1, if you put z equals to 2, if you put z equals to 3, so lambda by, first you will get 0, lambda by 2, 3 lambda by 2. Was that the same location? 0, lambda by 2. What was the location of maxima? 0, lambda by 2, lambda, 3 lambda by 2. This we did with the whole analysis. We did the whole analysis, then we got this final expression. But here what did I tell you? You just take the phasor, then you see this thing, that E naught will be already, it is a fixed value. Now I need to maximize this particular expression. How do I maximize? That 2 beta z should be equals to 2 n pi. So if that is equals to 2 n pi, z is equals to n lambda by 2 I am getting. So my maxima I am getting at 0, lambda by 2, lambda, 3 lambda by 2, 2 lambda, and then 5 lambda by 2. In that manner I will get. Now if I need minima, that means this should be equals to, or I should write in this manner, e to the power j 2 beta z should be equals to what? Minus 1. And when do you get minus 1? Sir, cos pi is minus 1. Cos pi is minus 1. So pi, 3 pi in that manner. So 2 beta z should be equals to what? 2n plus 1 pi. So it will be 4 pi by lambda z. So what we are going to get? 2n plus 1 lambda by 4. Okay. Here I will write only this thing. So z equals to 2n plus 1 lambda by 4. What is this? This is your minima. This is your minima. Were you getting the same thing? 2n plus lambda by 4. Here you are getting n lambda by 2. Yes. The same thing we are getting here. So phasor is a very important rule. Whenever any kind of expression comes, you just quickly calculate the phasor. In this step only you will get to know that sir, I will have to take e to the power minus j beta z outward, and directly you will write down this expression. And once you have written down this expression, this is a cakewalk for you. Right? If you have written down this expression, then you would know when it will be maximum, when it will be minimum. So we will never mug up any formula in this particular chapter. Like in this particular chapter, in this particular topic, people learn a lot of formula that sir, 2 beta z should be equals to 2n plus 1 pi, then this should come, then n value I should take 0 or 1. Nothing like that. No formula mugging up. Just calculate the phasor quickly and you will be able to write it down. We will solve more problems, like 10 more problems you are going to see. And after that you will be very, very comfortable. Okay. Now I know the maximum location, I know the minimum location. Now what will be the maximum and minimum value from this expression? Can you tell me what will be the maximum and minimum value? Maximum value. and minimum value. What that would be? Sir, E naught will be E naught only. 1 plus, this can give me maximum 1. So what will be the answer, sir? 2 E naught. Sir, E naught will be E naught only, sir. 1. What this can give me? Minimum, minus 1, sir. So answer will be 0. So maximum value you know, minimum value you know. Can you draw the standing wave pattern? Yes. How will you draw the standing wave pattern? That, sir, n equals to 0. That means at z equals to 0. Sir, at z equals to 0, I will get 0. Sir, at z equals to lambda by 4, sorry, at z equals to 0, I will get maxima. Really sorry. At z equals to 0, I will get maxima, and maxima is 2 E naught. Sir, at z equals to lambda by 4, I will get minima. At z equals to lambda by 2, I will get maxima. At z equals to lambda by 4, I will get minima. Maxima, minima. And maxima is 2 E naught, sir. And minima is 0, sir. There you go. You have drawn the pattern as well. And if I ask you standing wave ratio, then sir, 2 E naught divided by 0. That is, standing wave ratio is infinity. So every single question you have answered in within minutes, like within 1 minute you will be able to answer. And if you mug up the formula, you will never be able to answer correctly in the examination. And even if you do, it will take a lot of time, because you will take a lot of time to remember the formula itself, and you will not be confident enough in that answer. But here you will be confident enough. We will solve more problem. This was just the beginning. This is just the first problem that we have seen. Let's move to more problems. Let's see this question. So this question is coming in front of you, and they are asking you anything: maxima, minima, their location, what is the maximum value, what is the standing wave ratio, and they are asking you to draw the standing wave pattern as well. So how would you solve it? So first thing is, what did I say? Calculate the phasor. So sir, quickly I will calculate the phasor. I would get to know that, sir, it will be e to the power minus 2 beta z x cap plus, sir, this time it is having minus. So minus E naught e to the power j beta z x cap. Now sir, directly I will take the common outward. What I am going to get here, sir, which is this. This is what I am going to get. Okay. Now this is my ES. Now if I need to take the mode, in the examination I am not going to write down this step, because in the mind I will get to know that this is E naught only. So in the examination I will skip this step, but here for making the notes I am writing down this step. But in the examination, like some people would be directly writing this step. They would see e to the power minus j beta z, e to the power plus j beta z. Then that would come common, 1 minus e to the power 2 beta z. If I have been the student, then directly I will write down this step just by looking at the expression. You can write it down as well if you have enough practice. So 1 minus e to the power 2 beta z. Okay. Now I need to take maxima and minima. Tell me when you will get maxima. When you will get maxima. 2 beta z should be equals to 2n plus 1 pi. Why 2n plus 1 pi? Why 2n plus 1 pi? Because at 2n plus 1 pi, this will give you minus 1. And if it is giving you minus 1, then 1 minus 1, it should give you 2. Like 1 minus it is, no? Second example, 1 minus 5 e to the power j theta. So now I need it to be minus 1. And when it will be minus 1? That's our cos pi is minus 1. Cos pi is minus 1, so pi, 3 pi, 5 pi. So 2n plus 1 pi, 2n plus 1 pi. 2 beta, what it will become? 4 pi by lambda. 2 beta is 4 pi by lambda. 2 beta, 2 into 2 pi by lambda, that means 4 pi by lambda. So 2 beta is 4 pi by lambda. 2 beta is 4 pi by lambda, but what we need to do is that, let's shift it upward. Okay. So this way, this is your 4 pi by lambda is equals to z, 2n 1 plus pi. So z is equals to 2n plus 1 lambda by 4. So what is this? This is your maxima. And what about minima? So 2 beta z is equals to 2n pi. Why 2n pi? Because at 2n pi, that means at 0 degree it will give me 1. So 1 minus 1 will be 0. So that will be the minima. So from here I will get z equals to n lambda by 2. This is my minima. And if they ask you what is the maximum and minimum value, maximum value I am talking about, and minimum value I am talking about. So what will be the maximum value? E to the power 2 beta z should be minus 1, then you will get maximum value. That will be 2 E naught, and then it would be 0. If it is 1, it would be 0. So starting from 0, at z equals to 0, if I draw the standing wave pattern now, if I draw the standing wave pattern, so this is my z. and this is my magnitude, so I am not showing it. So at z equals to 0, if you put n equals to 0 here, basically where will be your minima? 0, lambda by 2, lambda, 3 lambda by 2, 2 lambda. At this point you will be having minima, and what is the minimum value? 0. And where you are having maxima? Maxima you are having at lambda by 4, then 3 lambda by 4, and so on. So you will start from 0, value will be 0, then goes upward, then again goes down, then goes upward, again goes down, then goes upward, again goes down. Initially you are having at z equals to 0, you are having your minima, and at z equals to lambda by 4, you are having your maxima, and at z equals to lambda by 2, again you are having minima, and at z equals to 3 lambda by 4, again you are having maxima. You can see here lambda by 4, 3 lambda by 5, 0 lambda by 2 lambda, 0 lambda by 2 again lambda. So in that manner it is going, and what is the maximum value? That is 2 E naught. So what is your standing wave ratio? 2 E naught divided by 0, again it is equals to infinity. Okay, this is your standing wave ratio. So this is how it is going. Is that clear to you? This is how we draw the pattern, right? And location of maxima, minima they are asking, maximum value they are asking, minimum value they are asking, the value of theta they are asking, anything they can ask, we will be able to write it down very quickly in a very good manner without even mugging up any formula. Is that clear to you or not? Okay, so in the same manner we are going to solve the problem. Let's solve this question. Here what is the different thing? 3 by 4 E naught is given. So what I am gonna do, first I am gonna write down the figure. That would be E naught e to the power minus j beta z Ex cap plus 3 by 4 E naught e to the power plus j beta z Ex cap, right? So what I am gonna take common, E naught e to the power minus j beta z Ex cap 1 plus 3 by 4 e to the power 2 beta z. Okay, this is my ES. And what will be its magnitude? Its magnitude again will be E naught magnitude of 1 plus 3 by 4 e to the power 2j beta z. Again maxima minima you need to calculate. So again it is very simple. Why it is simple? Because it is the same thing only. In previous cases we were having here 1. Now we are having 3 by 4. When we did this analysis, here we were having 5. So does that matter? No. When you will get maxima? When you will get maxima? When 2 beta z is equals to 2 n pi. Why 2 n pi? Because now you need it to be plus 1. If you need it to be plus 1, that means 1 plus 3 by 4, it will give you 7 by 4. So now you need it to be plus 1. So when you will get it plus 1? When 2 beta z is equals to 2 n pi. Because at like sound is coming. Because at 2 beta z is equals to 2 n pi. That means at angle 0 degree it would be 1. Cos 0 is 1. So 2 beta z is equal to 2 n pi. This we have understood a lot of times. So now I am not going to repeat it. 2 beta z should be equals to 2 n pi. And here 2 beta z is equals to 2n plus 1 pi. Why 2n plus 1 pi? Because at pi, cos pi is minus 1. So I need it to be minus 1. So what I am going to get here? Z equals to n lambda by 2. And here I am going to get, you can solve it, z equals to 2n plus 1 lambda by 4. So this is your maxima. Maxima you will get at 0, lambda by 2, lambda, 3 lambda by 2. And this is your minima. Where do you get your minima? So at lambda by 4, and then 3 lambda by 4, then again lambda by 2, that would be plus lambda by 2, that would be lambda में lambda by 4 जोड़ दो भाई, 5 lambda by 4, in that manner it will be going. Okay, so this is your location of maxima, this is your location of minima. And what is the maximum and minimum values? Maximum and minimum value. What will be the maximum value? What do you think? This should be 1. So what will be the maximum value? 7 by 4 E naught. For minimum value, this should be minus 1. So 1 minus 3 by 4, what that would be? 1 by 4 E naught. Is that clear to you? This should be 1. So 1 plus 3 by 4, 7 by 4 E naught. And this should be minus 1. So 1 minus 3 by 4, that would be 1 by 4 E naught. So maximum value is 7 by 4 E naught. Minimum value is 1 by 4 E naught. What do you think? What will be your standing wave ratio? Standing wave ratio. 7 by 4 E naught. divided by 1 by 4 E naught. Because maxima divided by minima, maximum value divided by minimum value. So what you are getting? Standing wave ratio is 7. So this is how we calculate the standing wave ratio. Is that clear to you? Standing wave ratio is 7. And if I ask you to draw the pattern, I have already drawn the pattern. 0 at lambda by 4. At 0 what you are having? Maxima. And what is the maximum value? 7 by 4 E naught. So at 0 you are having maxima, maximum value is 7 by 4 E naught. And at lambda by 4 you are having minima, value is 1 by 4 E naught. At lambda by 2 you are having maxima, lambda by 3 lambda by 4 you are having minima. What do you notice here? This is your maxima, this is your maxima. What is the distance between two maxima? Lambda by 4, lambda by 2. And what is the distance between two minima? Lambda by 2. And what is the distance between consecutive maxima and minima? Lambda by 4. Did you understand this point? Between two consecutive maxima, the distance will be lambda by 2. Between two consecutive minima, the distance will be lambda by 2. Between two consecutive maxima and minima, distance will be lambda by 4. Everything was happening same. Same thing was happening here as well. What was the distance? Lambda by 2. What was the distance between maxima and maxima? Lambda by 2. And what is the distance between maxima and minima? Lambda by 4. The concept here is that now you need to analyze whether first maxima will occur or minima will occur. Here first minima is occurring. In this case, first maximum was occurring. In our next case, first maxima is occurring. In the next case, what may happen? First minima can occur. So anything can happen. So in that manner, we need to analyze. I hope you are understanding the point. I hope you are enjoying the lecture as well. And this is one of the topical concept, not topical, one of the typical concept that we have simplified. Let's solve one more problem. Do it on your own. Same kind of problem is there. You need to draw the standing wave pattern. You need to tell me maxima, minima value. At what value you will get maxima, at what value you will get minima, and what will be the maximum value, what will be the minimum value, what will be your standing wave ratio. Here also I am writing standing wave ratio. What is my standing wave ratio here? That is 7 by 4 E naught divided by 1 by 4 E naught. Standing wave ratio is coming out to be 7. Okay. So let's start this. So what I'm gonna do, I'm gonna calculate the phasor. I hope you must have done it on your own. Okay, if you have done it on your own, then simply check the answer if you have done it correctly or not. And hopefully if you are listening to the lecture carefully, if you are having good amount of patience, then certainly you would have done it correctly only. Can I write it down directly? Yes, now. I am directly writing down the mode. What that would be? E naught e to the power j beta z minus ax cap, that would be coming out, and that will have E naught mode. And in between what you will be left with? 1 minus 3 by 4 e to the power 2 beta z. So in the examination you will be writing down this expression. You will be writing down this expression very easily and very fastly as well. First just convert it into phasor and then just took it out, and 1 minus 3 by 4 E naught e to the power 2 beta z. What is phasor? Everything we have studied. All these things we have studied, right? Now maxima and minima. Where will maxima occur? What do you think? 2 beta z should be equals to what? 2n plus 1 pi. Why? Because cos pi is minus 1. Cos pi is minus 1, and if it is minus 1, then I will get 1 plus 3 by 4. So what will be the maximum value? What will be the maximum value? So E naught will be E naught only. 1 plus 3 by 4, because this can give me minus 1. If it is giving me minus 1, so that would be 7 by 4 E naught. And what about minima? This can give me plus 1. So 1 minus 3 by 4. That would be my minima, that would be 1 by 4 E naught. So here also standing wave ratio is 7 only. What is your standing wave ratio here? That is again 7. Maxima by minima, that is again 7. Standing wave ratio is 7 only. Now we need to find out the location. So from here we got the location as well. Okay. So Z is equals to 2n plus 1 lambda by 4. This is the location of maxima. Okay. So you will be starting from lambda by 4, then 3 lambda by 4, then 5 lambda by 4, and so on, right? Because if you put n equals to 0, what you are going to get? Lambda by 4, 3 lambda by 4. So at z equals to 0, you are certainly not having any maxima. So what you will have there? Minima. Let's check that out. So for minima, what is the case? 2 beta z should be equals to what? Your 2 beta z should be equals to 2n pi. So z equals to what you are going to get? N lambda by 2. So this is your location of minima. And if I put the values, so 0, it will be 0 only. Then n equals to 0, it will be 0. Then 1 lambda by 2, then lambda, then 3 lambda by 2, and so on. So what you are having? Next page is waste. This page is waste only. Yeah. So what you are having? Initially, you are having minima that will start from 1 by 4 E naught. Then you are having maxima that will go to 7 by 4 E naught. So this is how you will draw its pattern, right? This is your 0, then lambda by 4, lambda by 2, 3 lambda by 4, lambda. In that manner you are going. Initially you are having E by 4, then you are having 7 E by 4. Is that clear to you? Right? Everything is crystal clear. And what is the standing wave ratio? For standing wave ratio, it doesn't matter whether minima is occurring first, whether maxima is occurring first. No. Standing wave ratio is only the ratio of maxima by minima. So that would be 7 by 4 E naught divided by 1 by 4 E naught. So that would be 7. So this is just a representation of standing wave. Actually, standing wave is always dancing. It is always dancing like this, right? That we have already seen in the animation as well. So actual standing wave always dances. This is just how we represent a standing wave pattern. Okay. So in standing wave pattern, the negative value is also taken as a mode. So let's revise. Should I revise everything what we have studied? No. Before, let's solve this question. After that we can revise, because after that we will move to our EM wave only. Okay. So this is the last part of mathematics. After that we will study EM wave. Again we will go to EM wave, how EM wave generates a standing wave pattern, that you must have understood, because there will be a forward traveling wave, then there will be a backward traveling wave as well, because once we go from medium 1 to medium 2, this will be incident, then there will be some reflected wave as well, and both superimposed will make standing wave pattern, right? This is going into plus z, this is going into minus z, so both combined will make a standing wave pattern. Okay, so let's check that out. What I'm gonna do is that here, what is the interesting thing? This is the interesting thing, that you are having e to the power j pi by 3. Another thing you are having, basically this guy is not 3 by 4 only. Now this guy is complex. This is having some angle as well. So 3 by 4 e to the power j pi by 3. So no issue. Again we will apply the same thing. What I'm gonna do? Phasors. E naught e to the power minus j beta z ex cap plus 3 by 4 e to the power j pi by 3 e to the power j beta z ex cap. So e naught e to the power minus j beta z ex cap 1 plus e to the 1 plus 3 by 4. This is your e naught here. One plus 3 by 4 e to the power j 2 beta z plus pi by 3. Is that clear to you? What did I do? E to the power j beta z plus pi by 3 was there, and I am taking this common. This is simple mathematics. Then it would be e to the power j 2 beta z, e to the power j 2 beta z into e to the power j pi by 3, right? And if I add both of them, then power will be added. These two are in multiplication. If two guys are in multiplication, a to the power x into a to the power y, so a to the power x plus y. So I will just add them up. Okay. So just I took common, nothing else. And whenever anything is there, e to the power j pi by 3, that will be remaining as it is when we calculate the phasor. When we calculate the phasor, what do we eradicate? We only eradicate time term and real or imaginary term. Like real, this term will be eradicated, and e to the power j omega t, this term will be eradicated. Nothing will happen to this guy. This guy will come as it is. Right? I hope you know how to calculate the phasor, because we have seen it in a very in-depth manner. Okay. Now what will be your mode of ES? Mode of ES will be E naught and the mode of this guy. Now I need to calculate maxima and minima. So let's take it to the next page. Let's take it here. So mode of ES is E naught, just a second, E naught 1 plus 3 by 4 e to the power j 2 beta z plus pi by 3. Now maxima and minima I need to calculate. Now this angle should be equals to 2n pi. What did we study? 1 plus 5 e to the power j theta. 1 plus 5 e to the power j theta. So theta, this angle has to be equals to 2n pi for the maxima. Now this angle has to be equals to 2n pi. And why 2n pi? Why not a 2n plus 1 pi? Because here there is plus. If there is plus, that means I need this value to be 1. And if I need this value to be 1, that means 2 beta z plus pi by 3. If I need this value to be 1, that means 2 beta z plus pi by 3 should be equals to what? 2n pi. Is that clear to you? And 2 beta z plus pi by 3 should be equals to 2n plus 1 pi. Is that clear to you or not? And from here, if I need to calculate maximum and minimum value, then there is no doubt about that. It will be 7 by 4 again, maximum value and minimum value. So it would be 1 plus 3 by 4, so 7 by 4 E naught, and 1 minus 3 by 4, it will be 1 by 4 E naught. So what will be the standing wave ratio? Standing wave ratio will be 7 only. What is the standing wave ratio? 7 by 4 E naught divided by 1 by 4 E naught, it would be 7 only. So there is no change in standing wave ratio. Now we need to find the location of maxima and minima. So that is a task for us. So let's find it out. So this will be 4 pi by lambda into z, 2n pi minus pi by 3. Okay. So pi and pi gets cancelled. What is the value of z you are getting? Lambda by 4, 2n minus 1 by 3. Is that clear to you? And from here, what you are getting? This would be 4 pi by lambda. So 2n plus 1 minus 1 by 3 pi. Pi and pi get cancelled. Z is equals to lambda by 4, 2n plus 1, 2 by 3. This is your maximum. This is your minimum. Okay. Now tell me one thing. If I put n equals to 0 here, what I am getting? Z equals to minus lambda by 12. Is that possible? How can I get negative? It's not possible, right? Z equals to minus lambda by 12. It is not even possible. So n equals to 0 has to be eradicated. This cannot come in action. So we will start from n equals to 1. So this is the biggest doubt in the students, that sir, when n will start from 0, when n will start from 1, because those guys will mug up this formula. Student will mug up this formula and then they will think that sir, when it will start from where. So the simple thing is, I am not mugging up any formula. I will derive this thing in the examination. Quickly I will write down 2 beta z plus pi by 3 is equal to 2n pi. From there I will derive this thing. Then if I put n equals to 0 there, what do I get to know? That I get to know that sir, z equals to minus lambda by 12. That is not even possible. Z has to be positive value there. So this is, if this is not possible, then n equals to 1 I will put. So n equals to 1 if I put, what I get? 2 minus 1 by 3. That would be 5 by 2 minus 1 by 3. 5 by 3. So 5 lambda by 12 I am getting. Z equals to 5 lambda by 12. What will be next? So 4 minus 1 by 3, that would be 11 by 3. So 11 lambda by 12 you are getting. What actually happened here was minus lambda by 12. Actually this will be certainly your maxima. Certainly this will be maxima. Basically, how do you draw the maxima? This is how do you draw the standing wave pattern? In the increasing direction of z. But if I go back, so here also the same pattern would be there, no? So certainly z minus lambda by 2 will be your maxima. There is no doubt about that. But we are taking from z greater than 0. So if minus lambda by 2 is one of my maxima, then where will be my next maxima occurring? If you see this pattern, so first maxima was at lambda by 4. If I need to find where will be my next maxima, what I need to do? Plus lambda by 2, right? that would be 3 lambda by 4. What I mean to say is that my first maxima was at lambda by 4. That means my second maxima, where will be my second maxima? Lambda by 4 plus lambda by 2, because I told you the distance between them, distance between two consecutive maxima and two consecutive minima will always be lambda by 2. So this I have found, then what I will get? 3 lambda by 4. This I can see from the graph, but if I have calculated the first guy, then I can calculate the other guy as well. Here you can do the same thing. 5 lambda by 12. Then if I add lambda by 2, what you are going to get? 6, it will be 11 lambda by 12. If I multiply 6 here, then it will be 12. So 11 lambda by 12. So this is the second one, 11 lambda by 12. So in that manner, you can calculate. Okay. So minus lambda by 12 was certainly our answer, but that we will not take in action. Why we are not taking that in action? Because we are calculating for z greater than 0. Now, if I don't even do this calculation, do I need to do this calculation? No. In the examination, I don't need to do this calculation. I will only calculate maxima. If I have the location of maxima, what is the location of maxima? 5 lambda by 12. This is the first location of maxima. Can I calculate the location of minima? Yes. Let's go here. I have the location of maxima is lambda by 4. Location of maxima I am having. Now I need to calculate the location of minima. How can I calculate? What did I tell you? Between one maxima and one minima, the distance is lambda by 4. Between one maxima and one minima, the distance is lambda by 4. So simply subtract lambda by 4 from here. What you are getting? 0. Yes. Basically, your first maxima is at lambda by 4. From here, if you need to calculate first minima, that would be, sir, lambda by 4 minus lambda by 4. That would be at 0. Yes, you are getting at 0. Now, some guy will say that, sir, here I am having my first maxima. Sir, I am having my first maxima at 0. Now, if I need to calculate first minima, then, sir, will I do 0 minus lambda by 4? So, answer is coming out to be minus lambda by 4. This is not accepted. Minus lambda by 4 is not accepted. Then, to get the accepted answer, that means to get the first actual minima, what you need to do? Add lambda by 2 from here. What you are going to get? Lambda by 4. So yeah, at lambda by 4 you are having minima. Is this discussion clear to you? What I am doing? That means if I am having the location of first maxima or minima, then I can find anything. I just need the first location. If I have the first location of maxima, then I can tell you the first location of minima as well. What I did, I subtracted lambda by 4. Then I got to know that minus lambda by 4 is not even accepted. Then what you can do, simply add lambda by 4. That will be your first minima. Or you can do that minus lambda by 4 is not accepted. That means where will be my next minima? My next minima will be lambda by 2 apart. So plus lambda by 4 I did and lambda by 4 I got. This is how I can do. And here when I subtracted 0 was accepted. From 0 to infinity anything can be accepted, but negative value cannot be accepted. So if negative value is not accepted, so for that I can add lambda by 2, because if that is my first minima which is not accepted, then next minima will be lambda by 2 apart. So lambda by 2 I can add. So in the examination I am just telling you a shortcut. In the examination I will do only this calculation, then I will put n equals to 0. If I put n equals to 0, what I am getting? Minus lambda by 12. I will get to know that this is not accepted. What I am going to do? Lambda by 2 I will add. If I add lambda by 2, what I am getting? 5 lambda by 12. So this is my first maxima. What is this? Maxima. Now from here if I need to go to the minima, what I will do? 5 lambda by 12 minus lambda by 4 I will do. Minus lambda by 4 I will do. So what I am getting? 3 lambda by 12, right? Sorry, 2 lambda by 12. Yeah, 2 lambda by 12. That means I am getting lambda by 6. Lambda by 6 is accepted? Yes. So this is the first location of minima. Lambda by 6. Is that clear to you? Always I will subtract first. Why I am subtracting first? Because I need to know that first whether maxima is occurring or minima is occurring. I do not even know that first maxima will come or minima will come. So for analysis of that first maxima is coming or minima is coming, first I will subtract that. Let's just say, sir, this is my maxima location, but I am not sure. Who knows, here you are having minima. So I am not sure whether I will have first minima or maxima. Right? Is that clear to you? Okay, so let's draw the standing wave pattern. You will understand it more. So this standing wave pattern will be more interesting. So if you calculate the location of minima here, what you are gonna get? So n equals to 0 you can start. If I put n equals to 0, what I am gonna get? Z equals to if I put n equals to 0, what I'm gonna get? I'm gonna get lambda by 6, right? So lambda by 6 is accepted. So if I write down the value of minima, lambda by 6 plus lambda by 2, that would be 4 lambda by 6, so that would be 2 lambda by 3, right? Lambda by 6 plus lambda by 2, 3 and 6, 4 lambda by 6, that would be 2 lambda by 3, okay? 2 lambda by 3, in that manner we will go, okay? Lambda by 6, 2 lambda by 3, in that manner we will go. Now what do you think what will happen at z equals to 0? So at z equals to 0, you are neither having maxima, you are neither having minima. At z equals to 0, you are neither having maxima and neither having minima. At z equals to 0, what you are having? Put z equals to 0 here. What I got to know is that now there is something different, that in the previous cases, at z equals to 0, either I was having maxima or minima. Here I was having maxima. In this case, I was having minima. Now at first minima I will have at lambda by 6. Then I will have the maxima at 5 lambda by 12. So at z equals to 0, what I will be having? At z equals to 0, I will be having this value. What is this value? E naught 1 plus 3 by 4 e to the power j pi by 3. So you can calculate this value if you want to, but this is the value you will have at z equals to 0. So in the examination, I am not gonna do all these calculation. In the examination, I will just pick it up. I will put it equals to 2n pi. Once I put it equals to 2n pi, what do I get to know is that n equals to 0 is not accepted. At n equals to 0, I am getting minus lambda by 12, so that is not accepted. So I will add lambda by 2 because that will be my first location of maxima. So if I add lambda by 2, I will get 5 lambda by 12. So this is the location of my first maxima. Now if I know the location of first maxima, so from here to here can I go? Yes. So from first I will try 5 lambda by 12 minus lambda by 2. So I tried this, what do I get to know? Lambda by 6, positive, accepted. So lambda by 6 is accepted. So first minima is at lambda by 6. Then add lambda by 2, that will be your second minima. What you are getting? 2 lambda by 3. So this is my second minima. In that manner I can go. Is that clear to you? Okay. And then I got to know that at z equals to 0, I am neither having maxima, I am neither having minima. At z equals to 0, I am neither having maxima, I am neither having minima. So at z equals to 0, I am having some other value, which is this. So how will I draw the standing wave pattern? So how would I draw the standing wave pattern? So this is how I would draw the standing wave pattern. So this is my z and this is the magnitude axis. So at z equals to 0, you are having some value which you don't know. And what is the maximum and minimum value? Minimum value is 1 by 4 e naught and maximum value is 7 by 4 e naught. So at z equals to 0, you are having this value which I am calling e naught 1 plus 3 by 4 e to the power j pi by 3, and certainly we are talking about magnitude, so I will take the magnitude. This is the value you are having. Then at lambda by 6, you are having minima. At lambda by 6, you are having minima. Then at 5 lambda by 12, you are having maxima. Then again minima. What is this? Then again minima. This is 5 lambda by 12, this is your 2 lambda by 3. Then again maxima, then again minima, then again maxima, again minima. In that manner we will go, right? What this value will, this axis will be z, 5 lambda by 12, that will be 11 lambda by 12. So 2 lambda by 3, if I add lambda by 2, what do I get? 6, 4 lambda plus 3 lambda, that you are getting 7 lambda by 6. So the next value will be at 7 lambda by 6. Okay. So this expression, what is the value of this? This is your minimum value is 1 by 4 e naught. So value of this is 1 by 4 e naught. And what is the value of this? That is, sir, 7 by 4 e naught. So it feels like that this analysis is very big. In the examination, we will not be able to do this analysis. You actually do not need to do this analysis. Once you get this expression, you just put it equals to 2n pi. You get to know which one will be accepted, which one will not be accepted. In that manner, you can do your analysis. And once you know first maxima, you can always calculate first minima. You can always calculate your other minimas as well. Once I know this first maxima, what I am going to do is that I am going to subtract lambda by 4 from there. So I will get my first minima. That is lambda by 6, which is accepted. Let's just say this was instead of 5 lambda by 12, this was 3 lambda, not 3 lambda by 12. Instead of 5 lambda by 12, I was getting my first maxima at 2 lambda by 12. Let's assume that at lambda by 6, I am getting my first maxima. This is what I am assuming. Then what I would have done? That, sir, I will subtract lambda by 4 from it, and I will see whether I will get a minima or not. So what I am gonna do? Lambda by 6 minus lambda by 4. What do I get? 12, 2, 3 minus lambda by 12. I got to know that minus lambda by 12 is not even accepted. So this is not the location of my first minima. What is the location of my first minima? Sir, minus lambda by 12 plus lambda by 2. So what you will get here? 6, 6, that will be 5 lambda by 12. So your location of first minima would have been 5 lambda by 12, and your location of first maxima would have been lambda by 6. Then if you need second location of maxima, what you will do? Plus lambda by 2. So lambda by 6 plus lambda by 2, what you will get? 2 lambda by 3. So always you first subtract. First you calculate the maxima, then you subtract. Once you have subtracted, what you will understand? That whether your minima is accepted or not. If it is not accepted, that means the subtraction was wrong. That means you need to add lambda by 2 more. Because I am not having minima at minus lambda by 2. I will have to add lambda by 2 more. So at lambda by 2 ahead, I am having my first minima. So that is my 5 lambda by 12. So in that manner I will do. So always first I will calculate my maxima, then I will subtract, and then I will see whether it is acceptable or not. If it is not acceptable, then I will have to add lambda by 2. Is that clear to you or not? So in the examination, this feels like a very big calculation. I am not asking you to mug up any formula, but this calculation will be very easy once we solve the problem. Okay, we will solve the problem, you will realize it is very easy. Now we are going to move towards EM wave, but since it is 80 minutes, I will take a break. You can also take a break. Okay, get a pause, revise everything that we have studied. Just revise everything that we started with standing wave pattern. Now first we started with mathematics, then we make a very good conclusion that this has to be 1 for maximum value, and for minimum value this has to be -1. So from there we can get the value of theta. That was the good conclusion that we made. Then we understand the standing wave pattern, that how standing waves are generated. This is how the standing wave is generated, that one node is always fixed and one node is dancing. This is known as node, this is known as anti-node, but that is not useful for you. That what do we call what? No one will ask you, but you got to know that standing wave means waves will be dancing, and this is how we saw the animation as well. Okay, so you must have understood the difference between traveling wave and standing wave. Okay, then we saw how do we draw the standing wave pattern. So always the negative value will be taken as a mode. So always we take the negative value as a mode. Then we go to know what is standing wave ratio. Then we get to know how to solve a problem. So always we will calculate the feature. Then we will see maximum and minimum value. So for maximum value, what do we know? What do we need? We need +1 or -1. That we need to see whether we need +1 or -1. In this example, for maximum value, we will be needing +1. And once I have calculated the location of maxima, that means if I put n equals to 0, what I am getting? Z equals to 0. That means my maxima is at Z equals to 0. My maxima is at Z equals to 0. Now if I need to calculate minima, what I am going to do? 0 minus lambda by 4. If I need to calculate first minima, what I am going to do? 0 minus lambda by 4. What did I get? That my first minima is at minus lambda by 4, which is not acceptable. Minus lambda by 4 is not acceptable. So what I am going to do? Plus lambda by 2. So what I will get? Lambda by 4. So my first minima will be at lambda by 4. Then lambda by 4. Then 3 lambda by 4. Then more, you can add lambda by 2, lambda by 2, you will get your location of minima as well. So this is how you will get your location of minima. Okay, I hope this is clear. You do not have to solve both of the things. You just need to solve one thing. From one to another, you can go without even solving it. So once I know the location of maxima, I can go to the location of minima very easily. Okay, so here also if I know the location of maxima, I can go to the location of minima as well. What is the location of maxima? Lambda by 4. First maxima at lambda by 4. So I will subtract lambda by 4. What I am getting? 0. Yes, it is acceptable. So my first minima is at 0. Then 0 plus lambda by 2 plus lambda by 2. In that manner it will go. So 0 lambda by 2 lambda 3 lambda by 2. In that manner it will go. Is that clear to you? Then I can draw the standing wave pattern. Same goes here as well, right? I will do the calculation. Just it was 3 by 4 this time. So if it is 3 by 4, then again I calculated the locations. Here if I do 0 minus lambda by 4, again it will not be acceptable. If minus lambda by 4 is not acceptable, what I am going to do? Plus lambda by 2. What I am going to get? Lambda by 4. So this is my first location of minima. Why I am doing plus lambda by 2? Because minus lambda by 4 is not even accepted. So my next minima will occur lambda by 2 apart. So minus lambda by 4 plus lambda by 2. So that will be plus lambda by 4. So my first minima will be at lambda by 4 and maxima at 0. So 0 lambda by 4, in that manner it will go. Is that clear to you? Then I draw the standing wave pattern as well. So in that manner we are studying it. Then we saw this example where minus sign was there, and then we saw this example where e to the power j pi by 3 was there. So another factor is coming, that is e to the power j pi by 3. So because of that we took this in action. Then what did we do? Then 2 beta z plus pi by 3 is equals to 2n pi. From there we go to know that this is our value of z. So the value of z is lambda by 4, 2n minus 1, 2n minus 1 by 3. So n equals to 0. So minus lambda by 12 is not accepted. Then certainly n equals to 1 I need to put. So if I put n equals to 1, then I go to know that 5 lambda by 12 is accepted. So from there if I add lambda by 2, then all the accepted things will come. And if I need to calculate minima from here, what I'm going to do, I'm going to subtract lambda by 4. If I subtract lambda by 4, I get to know that yes, I'm getting lambda by 6, which is accepted. So my first minima is at lambda by 6, and then from there I can calculate my other minimas as well. So this is how we studied our standing wave pattern. We did not move into EM wave. Now we have spent 90 minutes. Now we are going to move into EM wave, and you will feel very happy. So let me take a pause now. I will take a pause, then we will start into EM wave. That there will be some transmitted wave. Sorry, there will be some incident wave and there will be some reflected wave, and both superimposed will make a standing wave pattern. Is that clear? So let me take a pause and then we will come back. Yeah, so in the first half of this video, what did we study? We studied about standing waves. Now we are going to study about standing EM waves. Okay, so now we will discuss all these things which we have already studied in EM wave, and now the analysis will be very easy for you. It will be simply a cakewalk. You know everything, you just need to apply the formula. Sorry, no formula. We did not even understand any formula. You just need to apply the concept, and from that you will be able to solve every single problem. Okay, so how EM wave will generate a standing wave pattern? So this is a boundary. Let's just say this is a boundary, and incident wave will be there. Now some part will be transmitted and some part will be reflected back. So at this side of boundary, there will be incident wave and there will be reflected wave. So incident plus reflected wave, both superimposing will generate a standing wave pattern, because in the previous part of this video, what did we see? This was traveling in positive z direction and this was traveling in minus z direction. So one guy was traveling here, one guy was traveling here, both got superimposed and generated a standing wave pattern like this. Same thing is happening here. This is your incident wave, this is your incident wave. Let's just say this boundary plane is z equals to 0. So this region is z less than 0 and this region is z greater than 0. So for the region z less than 0, this is your z equals to 0, z greater than 0, z less than 0. For the region z less than 0, there is incident wave as well, there is reflected wave as well. And both superimposing, both when superimposed will generate a standing wave pattern. Standing wave pattern. And this is the theory that I have written, and I hope you already knew this thing because we have spent a lot of time here, right? Now what we need to do, we just need to do a simple analysis, and based on that we will solve the problem. So first let's do the analysis. So what is our incident wave? E naught e to the power minus alpha z cos omega t minus beta z. I am assuming any general medium, like it is, there is loss as well. So lossy medium, so any general medium I am assuming. So E naught e to the power minus alpha z cos omega t minus beta z ax cap. Okay. Now what will be a reflected wave? So for writing the expression of reflected wave, what you need to do? You need to multiply it with gamma E. You need to multiply your incident wave with gamma E. So this will be your magnitude, gamma E E naught. This we have studied in the previous video. In the previous video we studied how to write down the reflected wave, how to write down the reflected electric field, how to write down the reflected magnetic field, how to write down the transmitted magnetic field, how to write down the transmitted electric field. Why we are not caring about transmitted field? Why we are not caring about this? Because here only one field will be there, no? Only transmitted field will be there. So there is no superimposition of two waves. Here two waves are being superimposed. That's why you are generating a standing wave pattern. So standing wave pattern will be generated for z less than 0. Here there is no standing wave pattern. So that's why we are not caring about this transmitted wave. We are only caring about incident and reflected wave. So this is my reflected wave, e to the power minus alpha z. Everything will be copied same. Omega will always be same. Beta will also be same. Why beta is same? Because you are running in this medium only, and in this medium beta is same. But here plus will come. Why plus will come? Because this wave was traveling in positive z direction. This I am assuming this is my positive z. So now this wave is traveling in minus z direction. So that's why positive sign is coming and ax cap. Now whether this guy ax cap will be changing or not, whether it will be plus ax cap or minus ax cap, that will be taken care by this gamma E. If gamma E is becoming negative, that means electric field is changing its direction. So this concept we have already studied in the previous video. Now what will be the total electric field for the region for z less than 0? For z less than 0, what will be the total electric field? Just addition of both of them. So E naught e to the power minus alpha z cos omega t minus beta z ax cap plus gamma E naught e to the power minus alpha z cos omega t minus beta z ex cap. Now, what do you know about gamma? What is gamma e? Neta 2 minus neta 1 upon neta 2 plus neta 1. This neta can be complex, right? Neta can be complex because what is the formula of neta? J omega mu upon sigma plus j omega epsilon. So this could be complex, this could also be complex. So basically gamma e is a complex quantity. Gamma e is a complex quantity. So basically your gamma e can be written as that it will have some magnitude and some angle as well, right? So what I am gonna write? What I am gonna write this expression? So how I'm gonna write my total electric field now? So E naught e to the power minus alpha z cos omega t. Here it is plus beta z. Sorry, this is plus beta z minus beta z ex cap. So gamma e I am writing as magnitude and then the angle. Okay, then E naught e to the power minus alpha z cos omega t plus beta z ex cap. Now if I write down the phasor form of this, because how do we analyze the standing wave? By calculating the phasor. This we have seen in the first half of this video. So now I will calculate the phasor. So E naught e to the power minus alpha z e to the power minus j beta z ex cap. Here gamma e. Then what will happen here? E to the power minus alpha gamma e. Then E naught e to the power minus alpha z. Now e to the power j theta e and e to the power j beta z both will be added, right? E to the power j beta z plus theta e. Look, this derivation you do not need to remember. In the examination you are not going to do this derivation there. Okay, we will solve the problem, but just for the theory purpose we are writing it down, and you are able to understand every single thing. You can write down all these steps on your own if you have studied the previous part of this video, right? So e to the power j beta z plus this theta e, okay, ex cap, right? Now what will come common? E naught e to the power minus alpha z e to the power minus j beta z ex cap. Complete part I will take common, and what I will be left with? 1 plus gamma e e to the power 2 beta z plus theta e, and that's it. Did you understand this point? What did I do? This part I took common. So completely I took common from here. So 1 was left here. Now what I did not pick? This I did not pick. So mod of gamma e. Then e to the power minus alpha z is gone, e naught is gone. Then e to the power j theta is also left. E to the power j theta is also left. And here it is e to the power j beta z. So that will be divided by e to the power minus j beta z. So what you will get? E to the power j 2 beta z plus theta e. Okay. You do not need to mug up this derivation. Just for the theory purpose we are writing it down. Now if I need maxima and minima, so what will happen? Now the thing is, this is a lossy medium. So certainly E naught will be always getting less. What I mean to say is that when we saw the standing wave pattern, what did we saw? That it is always dancing like this. Here there was no attenuation, right? With respect to Z, there is no attenuation. It is always at E naught. This is also always at E naught. But if I consider lossy medium, so how will I get my standing wave pattern? That you are having a maxima here, then it will be, the maxima will keep on going down. Okay. So this will happen. The maxima will also keep on going down since there is a loss with respect to Z. So if you go ahead in Z, the maxima will keep on going down. Okay, because there is an attenuation, because of this attenuation. Okay, so as of now we will do the analysis considering lambda alpha equals to 0. Okay, so considering lossless medium. So now take alpha equals to 0, considering and one more thing is there, that this will be plus alpha z actually. This will be plus alpha z, no? Why this is minus alpha z? This will be plus alpha z, right? Here I will get plus alpha z, not minus alpha z. So this will also be plus alpha z, plus alpha z. This is also plus alpha z. So if I take it outward, then here also I will get a, if I take this alpha z, so here also I will get plus alpha z. So here only I am writing that I am assuming alpha equals to 0. Okay, if the question is coming from this particular chapter, then certainly it will be lossless. That's for sure. Like even if it is lossy, then you would know that it is going down. The standing wave pattern is going down. Basically, your wave will be dancing. But it will be keep on losing its amplitude as well. The wave will be dancing, but amplitude will be keep on getting less. So alpha equals to 0 will be asked only. In any book you see alpha equals to 0 condition they have taken. Lossless condition only they have taken. I just wanted to take this alpha here so that you could understand that even if there is alpha, then what will happen? The magnitude will go down. That is the only thing will happen. Is that clear to you? So we will take alpha equals to 0 condition, and I am 100% sure that if the question is coming, that will take from alpha equals to 0 only. And even if they are taking alpha into action, then what is the issue? You can still tell the answer. You will just take the alpha into action. What you will do here? You will put e to the power 2 alpha z. What this will do? This will keep there as it is, because this is not the deciding factor of maxima and minima. What is the deciding factor of maxima and minima? E to the power j theta. Whatever this angle is there, that is the deciding factor of maxima and minima. So from here you will get the value of maxima and minima. Let's just say I get that my z equals to lambda by 6. At z equals to lambda by 6, I am having my maxima. This is what I am getting. Assuming that at z equals to lambda by 6, I am having my maxima. So what does that mean? That this value will be 1. At z equals to lambda by 6, this value will be 1. So 1 plus gamma e to the power 2 alpha z. This will be my maximum value. This will be my maximum value. So at z, what I am going to put? At z I am going to put lambda by 6. So at z I will put lambda by 6, and at that point I will get my maximum value. Are you getting this point? Okay, I hope you are understanding it. What I am saying is that even if you take e to the power alpha z in action, then that will remain there as it is. It is not the deciding factor of maxima and minima. Deciding factor of maxima and minima is 1 plus e to the power j theta. This theta is the deciding factor. So first it will decide whether you will get, where you will get maxima, where you will get minima. Assuming that I am getting my maxima at lambda by 6. Let's just say I am getting my maxima at lambda by 6. Now they are asking what is the magnitude of maxima. So if they are asking the magnitude of maxima, then what you are going to do? What will be the magnitude? E naught e to the power minus alpha z 1 plus gamma e to the power 2 alpha z. This will be the magnitude. Now alpha value you would know, and at z equals to lambda by 6 you are having maxima. So you will put z equals to lambda by 6 here. You will put z equals to lambda by 6 here. Then you will get the magnitude. That's it. Okay. But there is very rare chance that this will be asked. Again I am telling, very rare chance that it will be asked. But still if they ask, then you have the capability of writing it down. Is that clear to you? Yes. Okay. So we will take lambda equals to 0. Sorry, alpha equals to 0, not lambda. We will take alpha equals to 0. Considering lossless medium. And did you understand why did I say here plus z will come? Because I am traveling in negative z direction. No? This wave is traveling in negative z direction. So if the value of z is becoming negative at z equals to 0, what is the magnitude? E naught. At z equals to minus 1, what will be the magnitude? At z equals to minus 1, the magnitude will be E naught e to the power alpha, and z is minus 1. So that will be E naught into e to the power minus alpha. At z equals to minus 2, magnitude will be less. And at z equals to minus infinity, what will be the magnitude? E naught e to the power minus infinity. That would be 0 only. So in this direction, basically if you draw this waveform, how it will go? It will go like this. Because z is negative. I am walking in this direction. Z is negative. Are you getting this point? Here I am putting plus z. Why I am putting plus z? Because I am walking in minus z direction. That means in minus z my coordinate is getting increased from minus 1 to minus 2, minus 3, minus 4, minus 5, minus 6. In that manner I am proceeding. So that means at z equals to 0 I have the magnitude of gamma e naught. At z equals to minus infinity I am having the magnitude of 0. Is that clear to you? Okay. So that's why I took plus z here. Or you can think simply, how you can think that if you are working in plus z, then what do you take? Minus. And if you are working in minus z, what you will take? Plus. Right? Omega t minus beta z, right? So whatever the sign you are having here, the same sign you are going to put here as well. That is very basic thing. But I was actually explaining the meaning of this. That if you are working in minus z, and why I am spending so much time here, because all these things will be introduced in our transmission line. Transmission line is simply this thing only, which we are studying right now. All is based on, your complete transmission line is based on this concept only. This ditto same thing you are going to do in transmission line, because there will be a incident wave will be there, and that will be reflected from the load, and it will come back, and both will be superimposed and will generate a standing wave pattern there. So the same thing we will study there, exactly same. So if we have spent time here, then there we do not need to spend the time. Okay. So that's why I am spending the time here. So I hope is this clear, these things are clear to you. We are considering alpha equals to 0. If we are considering alpha equals to 0, that means alpha will not come in action now. Okay. So this guy will not come in action. So let's remove this guy. Now if I calculate the magnitude, what I am getting, that is E naught and then magnitude of 1 plus gamma e to the power j2 beta z plus theta e. Again I am telling, we do not need to mug up any formula, any single formula we do not need to mug up. We will just do this analysis in the examination, and once we are having this expression, then what we can do? If we are having this expression, then can you let me know what will be the location of maxima and minima? Yes, certainly I can let you know the maxima and minima location. And can you let me know the maximum and minimum value? Yes, surely I can let you know the maximum value and minimum value. What will be the maximum value? At maximum value, this will be equals to 1. At maximum value, this guy will be equals to 1. So your maximum value will be E naught 1 plus gamma e. And what will be your minimum value? At minimum value, this guy will be minus 1. So your minimum value will be 1 minus mode of gamma e. That will be your minimum value. This is your maximum value, this is your minimum value. Okay. Now if I need to calculate maxima, and then I need to calculate minima. So for maxima, I need this guy to be equals to 2n pi. What I need? I need this guy equals to 2n pi. So 2 beta z plus theta e is equals to 2n pi. And for minima, I need this guy equals to 2n plus 1 pi. Why is that so? Because at 2n plus 1 pi, this will give me minus 1. Right? This we have already seen. We have spent a lot of time on this particular thing. That this will give us a minus 1 at 2n plus 1 pi. 2n plus 1 pi. So from here we can solve it and we will get the value of lambda. I do not remember the final expression. And from here, not lambda, sorry. From here we will get the value of z in terms of lambda. And from here also we will get the value of z in terms of lambda. That lambda expression I do not need to mug up. This expression also I do not need to mug up. What I need to keep in mind, that I will be having an incident wave, I will be generating a reflected wave, I will superimpose both of them, and then I will just calculate the phasor, and from there I just need to put this equals to 2n pi or 2n plus 1 pi. That I will see whether I need to put it equals to 2n pi or 2n plus 1 pi. Is that clear to you or not? Let's just say if my gamma e was minus 1. If my gamma e was minus 1, then which condition I will come to? If my gamma e was minus 1. If gamma e was minus 1, then this would be my expression. And this analysis I would be doing. If my gamma e was 3 by 4, then which analysis I would be doing? This analysis I would be doing. If my gamma e was minus 3 by 4, then this analysis I would be doing. And if my gamma e was 3 by 4 e to the power j pi by 3, then this analysis I would be doing. Which analysis? This analysis. So we have already studied all the pattern without even understanding that we have studied it. Okay, you did not even get to know that you have studied this topic. Previously only, in mathematics only we studied this topic. This was your gamma e only. Did you realize this thing? This is my gamma e, minus 3 by 4, plus 3 by 4, minus 1. And here gamma e was plus 1. So you studied this thing, just you did not know that I studied it. Are you getting this point? Okay. So from here I will get, this will be my maxima and this will be my minima. And then I can draw my standing wave pattern. But tell me one thing, what is my electric standing wave ratio? What I am getting as standing wave ratio? My electric standing wave ratio is coming out to be E naught into 1 plus gamma e divided by E naught into 1 minus gamma e. So electric standing wave ratio is equals to 1 plus gamma e mode of gamma e divided by 1 minus mode of gamma e. So this you can keep in mind. If you want to keep in mind, then this formula you can keep in mind, that what is your electric standing wave ratio. So if you are having the gamma e value, then directly you can calculate the standing wave ratio. Is that clear to you or not? Okay. So in that manner we will do the analysis. How we will do the analysis? First target would be, they will give us this equation. They will tell us neta 2, they will tell us neta 1. what I will calculate? Gamma E. Gamma E I will calculate. If I calculate gamma E, then I can get this expression. And once I get this expression, what I need to do? I just need to convert it into phasor. Let's say move it off. I just need to convert it into phasor. Just need to convert it into phasor and then do this analysis. There you go. Okay. Let's solve some question based on this. So this is EI expression is given. Okay. Medium 1 is free space. They have given that medium 1 is free space. F is equals to 100 megahertz. This they have given. This EM wave is incident on a perfect conducting plate. Perfect conducting plate it is incident on. Find the location of electric field maxima and minima. Find the location of magnetic field maxima and minima. You need to find the electric field standing wave ratio and magnetic standing wave ratio as well. So we need to analyze with respect to electric field as well, and we need to analyze with respect to magnetic field as well. So first let's analyze with respect to electric field. All the analysis I am doing for electric field now. Okay. Then with respect to that, can we do the analysis for magnetic field? Yes. So what will be my gamma E? Gamma E. Gamma E would be neta 2 minus neta 1 divided by neta 2 plus neta 1. For conductor, did we see it in the last video? Yes, in the last video we see it. For conductor, what is the value of neta? 0. So for conductor, all the wave is reflected back. No part is transmitted. Basically, this is your conducting plate. This is your conducting plate. This is my conductor. And this is my free space. So what will happen is that your EM wave will come. Whatever the EM wave comes, all the part will be transmitted back. This is your incident EM wave. Sorry, not transmitted back, I should say reflected back. All the part will be reflected back. And what is the best quality? I should not say best quality, I should say what is the important point to note out, that this electric field will change its direction, but magnetic field will not change its direction. This is your electric field. If it was in this direction and magnetic field was in this direction, then E cross H was giving you P. So now magnetic field will not change its direction, but electric field has changed its direction. Is that clear to you? Okay, right? This we have already seen in the previous video. So neta value we will get is, sorry, not neta value, gamma E value we will get is minus 1. So what will be my reflected wave? ER I am writing. So what that would be? Minus E naught, E naught is 6. So minus 6 cos omega t plus beta z Ax cap. Is that clear to you? And what will be the total? Now can I write down the phasor directly? I am writing down the phasor of the total electric field in this medium, in this free space, in medium 1. I am writing down the phasor of this complete quantity, phasor of this plus this. So what I am writing? ETS is EIS plus ERS. So 6 cos omega t minus beta z. Okay, I am writing phasors. So what I will write? 6 e to the power minus beta z Ax cap minus 6 e to the power j beta z Ax cap. So what I need to take common? 6 e to the power minus j beta z Ax cap 1 minus e to the power 2 beta z. Now if you need to calculate maxima and minima, can you calculate it? Yes. What you can do from here? So let's write it down on the next page. So what is the magnitude of ETS? This analysis you will be doing very easily in the examination. What you will see, sir, perfect conducting plate. Okay, 6 perfect conducting plate is there. That means electric field will change its direction and complete part will be reflected back. So what you will write, sir, in the examination I will write the 6 e to the power minus j beta z Ax cap. I will actually drop this Ax cap because I know that is of no use. So this is what I will be writing in the examination. And then, sir, I know that, sir, minus 6 e to the power plus j beta z it would be. Why plus j beta z? Because direction will change. Now wave is propagating in minus z. Okay, then I would know that thing that, sir, this will be coming out with 6, and then here I will be having 2 beta z, and from there I will do the analysis. That, sir, this will give me magnitude 6. If I need the maximum value, that means this will give me minus 1. So 1 plus 1. So what I will be getting? 12. And if I need the minimum value, what I will be getting? 0. So what is my standing wave ratio? Infinity. Okay, and if I need to find the maxima and minima, that also I can find. So better mugging up the formula. If you mug up the formula, then you will be confused in the examination. That I can guarantee you. But if you go by the concept, if you simply do these things in paper, in the examination, you will never feel like that you are lagging behind, and you will have good confidence in solving those problems. 2 beta z. Now tell me one thing, when you will get maxima and when you will get minima. Now forget about maxima and minima. What I will do, I will only calculate maxima. I will only calculate maxima now. Because if I know the location of maxima, can I tell you the location of minima? Yes. So I will only calculate maxima. So when do I get maxima? 2n plus 1 pi. Why 2n plus 1 pi? Because cos pi is minus 1. Cos pi is minus 1. So I need it to be minus 1 so that I get the maximum value. So what is your maximum value and what is your minimum value? Maximum, minimum. So that would be 6 into 1 plus 1, 12, and minimum will be 6, 1 minus 1, that would be 0. So from here if I calculate ESWR, that is coming out to be 12 by 0, that is infinity. And if I had calculated this using the formula, then what I would have got? ESWR is 1 plus mode of gamma E divided by 1 minus mode of gamma E. So what you would have got? 1 plus 1, 2, 1 minus 1, 0. What you would have got? Infinity. So here also you would have got infinity. There is no doubt about that. Okay. So if they only ask me about ESWR, then I will apply the formula. This formula I will apply. But if they ask me location of maxima minima, then I will do the analysis. So 2 beta z should be equals to 2n plus 1 pi for maxima. So this will be your 4 pi by lambda z 2n plus 1 pi. So what you are getting? Z equals to 2n plus 1 lambda by 4. This is the location of maxima. Okay, this is the location of maxima. So from here, what all things you are getting? You are getting maxima at what you are going to put? Sir, I will start putting n equals to 0. So from n equals to 0, what you are going to get? Lambda by 4, 3 lambda by 4, and then in that manner I will go. Okay, then again lambda by 2 will be added. So what you will get? 5 lambda by 4. In that manner I will get my maxima. So for minima, what do I do? If my first maxima is at lambda by 4, then my first minima should be lambda by 4 behind, right? That is at 0. Is that acceptable? Yes. So my first minima will be at 0. So where will be my minimas? So first minima is at 0. Second would be at lambda by 2. Third, fourth, in that manner we will go. So can I draw my standing wave pattern now? Yes. And here I am writing ETS mode. Now tell me one thing, why I am drawing the standing wave pattern here? I will draw the standing wave pattern like this. Why is that so? Because this is all happening for z less than 0. No? This all is happening for z less than 0. Here it is happening. This all is happening for z less than 0. That's why I am drawing my standing wave pattern here. Okay. So I will start from here. This all is happening for z less than 0. That's why I will, and at z equals to 0, what I am having? At z equals to 0, I am having minima. So I will start from, I will go in the negative z direction. This is my negative z direction. So I will go in the negative z direction. So this is how I will draw. It is very tough to draw it opposite. Okay. I will waste your time here. If you don't want your time to be wasted, then skip this part until I make this. Okay. Somehow I have made it. Okay. So yeah. So this is your 0. This is your lambda by 4, lambda by 2, 3 lambda by 4, lambda. So at 0, lambda by 2, lambda you are having minima, and all those points you are having maxima. And what is the maximum value? That is 12. So this is 12. Is that clear to you? Will you be able to solve the problem? Certainly you will be able to solve the problem because you have your concepts clear. So all these problems will come in this kind only. All these problems will come, such kind of problem can come, that they can ask you to calculate gamma E. You will get gamma E like this. Then they will ask you the location of maxima and minima. So this is how you will do the analysis. They will ask you the value of gamma E. It will come out to be -3 by 4. Then you will calculate maxima and minima. So everything that we wanted to study in EM wave, that we have already studied in these examples. Is that clear to you? Okay. So now we will see more examples. More examples are there. So yeah, this example is not completed. We studied with respect to only electric field. Now we need to study it with respect to magnetic field. Okay. So I will add 2 more pages. We need to study it with respect to magnetic field as well. So let's study it with respect to magnetic field. So what will be my HI? That was 6 by neta cos omega t minus beta z ay cap, right? What will be your HR reflected? So from here I will calculate HR. If I have the expression of ER, I can calculate HR. So from here, if I want to calculate HR, from this expression, if I want to calculate HR, then what it would be? 6 by neta cos omega t plus beta z ay cap only. Because what will be your AH direction? What we know, P is equals to E cross H. So H will be P cross E. What is the direction of P? Minus AZ cap. What is the direction of E? Minus AX cap. Minus minus gets cancelled. AZ cross AX, what it will give you? AY. So your magnetic field will be in AY direction. And what is the other way of proving it? The other way of proving it is that this field will be in, here your magnetic field will be in AY direction only. And since gamma is becoming negative, gamma E is negative, that means certainly gamma H will be positive. And if gamma H is positive, that means magnetic field is not changing its direction. Here also we can tell magnetic field is not changing its direction. This was your AHI and this is your AHR. So magnetic field is not changing its direction. Okay. So what will be the expression of these? We have already studied in the previous video, that how to write down HR expression. HR I have written from ER only. So 6 by eta cos omega t plus beta z ay cap. Okay. Now if I need to write H total, and directly I am writing the, what I am writing? Directly I am writing the phasor form. So what it would be? 6 by eta e to the power minus j beta z ay cap plus 6 by eta e to the power j beta z ay cap. A very important conclusion we are going to make from here. So 6 by eta e to the power minus j beta z ay cap 1 plus e to the power 2j beta z. Okay, this is your HTS. And if I ask you the magnitude, what do you get? 6 by eta 1 plus e to the power 2j beta z. Okay, and if you calculate the maximum value here and minimum value here, what will be the maximum value? Maximum value, it will be 1. So it would be, maximum value will be 6 by eta into 1 plus 1, that is coming out to be 12, and minimum value will be 6 by eta 1 minus 1, that is coming out to be 0. So what is your magnetic standing wave ratio? Magnetic standing wave ratio, what is that? 12 by 0, that is equals to infinity. So isn't that obvious that both are equal only? Why both are equal? Because what is your electric standing wave ratio? That is equals to 1 plus mode of gamma E divided by 1 minus mode of gamma E. Is that clear to you? And what do I know? That gamma E is equals to minus gamma H. Gamma E is equals to minus gamma H. That means if gamma E is 2, then gamma H is minus 2. But if I take the mode, then both will be equal. If I take the mode, then both will be equal. So what will be your magnetic standing wave ratio? That would be 1 plus gamma H divided by 1 minus gamma H. Here also you can see, here gamma H is 1 only. So 1 plus gamma H divided by 1 minus gamma H. And both are equal only. Why both are equal? Because gamma is equals to gamma H. Gamma is equals to gamma H. So that means electric standing wave ratio is equals to magnetic standing wave ratio. Both ratios are equal. Now let's analyze this, where you will get maxima. So let's take this expression, which is 1 plus e to the power 2j beta z. This expression I was analyzing, and 6 by neta, that is equals to your HTS magnitude. So where you will get maxima? So for maxima, 2 beta z should be equals to what? 2n pi. So what will be the z value you will get? N lambda by 2. So where is my maxima? Maxima is at 0, lambda by 2, lambda, 3 lambda by 2. This is the location of maxima. So my first maxima is at 0. So for first minima, what I will do? For first minima, I will subtract lambda by 4. If I subtract lambda by 4, what do I get? Minus lambda by 4, which is not acceptable. It is not acceptable. So what I need to do? I need to add lambda by 2. So what I will get? Plus lambda by 4. So my first minima will be at lambda by 4. So more minimas will be lambda by 4, 3 lambda by 4, and in that manner it will go. Is that clear to you? Always you will subtract first lambda by 4 to get the first minima, like previously you will see. But you got to know that previous is not even possible. You cannot even go back. Then you understood that I cannot go back. That means I need to go ahead. So lambda by 2 ahead I will get it. And did you notice one thing? Here I should put minus. So always I will do the calculation in plus only. I will do the calculation in plus, that 0 lambda by 2 lambda by 2. So I am doing the calculation in plus only. I do not even need to think of minus. But when I am drawing the standing wave pattern, then I am drawing it on this direction. That's why I need to put it minus, nothing else. Okay, don't get confused with plus minus sign. What I am saying is that I will do all my calculation in plus only. But when I am calculating the standing wave pattern, when I am drawing the standing wave pattern, then I go to know that I need to proceed in the previous part. I need to go back. So in this direction I am drawing it. Right? So now I have to make the standing wave pattern, and from there we will make important conclusions. So now I will generate my standing wave pattern, but for which I am drawing, this is your magnetic standing wave pattern. So at z equals to 0, what you are having? Maxima you are having. At z equals to 0, you are having maxima. So first you will start from maxima. And what is your maximum value? My maximum value is 12 by eta. 12 by eta. It was eta as well. So my maximum value is 12 by eta. So at initially I am having maxima now. In this manner it will go. Very tough. You just consider I made it like this only, okay? I drew it from here because it was tough to draw like that, but it would be, and these amplitude are also same. These amplitudes are not decreasing. That is 12 by eta. This is your z, this is your minus z, and this amplitude is 12 by eta, and this amplitude is 0. And what will be this? This will be 0, this will be lambda by 4, this will be lambda by 2, this will be 3 lambda by 4, this will be lambda. So where you are having your maximas? 0 lambda by 2 lambda. So 0 lambda by 2 and then lambda. So in that manner we are having the maximas. Is that clear to you? Say yes or no, right? So what did you notice here? First thing is that electric standing wave ratio is equals to magnetic standing wave ratio. This is the first conclusion we are making. Second, very important conclusion. At z equals to 0 you are having maxima. At z equals to 0 you are having H maxima. At z equals to 0 you are having E minima. You check it. At z equals to 0 you are having E minima. E minima. At z equals to lambda by 4 you are having H. At z equals to lambda by 4 you are having H minima. And at z equals to lambda by 4 you are having E maxima. You can check it. You are having E maxima. At z equals to lambda by 4 you are having E maxima. Although these are negative, I will do the calculation in plus only, but this is a negative, so I can put negative sign here. So what did you get to know? At the point when H maxima I am getting, at that point I will get E minima, and when I am getting H minima I will get E maxima. Is that clear to you? When H is at maximum, E will be minimum, and when E is maximum, H will be minimum. Is that clear to you or not? Okay. So what I can write is that location of maxima of E field is equals to location of, I am not talking about magnitude, I am only talking about the location, that at lambda by 4 here I am having minima, but in electric field I was having maxima. So location of maxima of electric field is equals to location of minima of H field, and location of minima of H field is equals to location of maxima of H field, E field, sorry, minima. Okay, wait a second, this is minima only, so both will make same sense only. So here I should write maxima of H field, maxima of H field is equals to location of minima of E field. So both will not be together maxima, or both will not be together minima. First electric field maxima, then magnetic field maxima, then electric field maxima, then magnetic field maxima, like maxima minima, maxima minima, in that manner it will go. So basically if I am saying that this is my magnetic field pattern, this is my magnetic field pattern, and now I am asking you to draw the electric field pattern, then if this is maxima, then it will start from minima. This is minima, so here it will have maxima, then in that manner it will go. Like it is not, I am not able to make it more clearly, but you have understood the point. Like basically this graph and this graph you can superimpose. So there you will get to know that when one is having maxima, other guy is having minima, then other guy is having minima, the previous guy was having maxima. Is that clear to you? And if they are asking maxima and minima location, then what you will do? You will do the analysis. One formula I understood, that ESWR or HSWR is equals to 1 plus gamma E divided by 1 minus. You will not get confused here, right? Why you will not get confused? Because what is this? This is maximum by minimum. So you will not confuse that sir plus will come or minus will come. So obviously here plus will come, and at downward minus will come. Why is that so? Why at downward minus will come? Because that is the minimum value, no? So here 1 plus gamma E and 1 minus gamma E. Distance between two local maxima, what is that? Lambda by 2. Distance between two local minima, lambda by 2. And distance between a minima and a maxima, lambda by 4. Right? I hope you remember this. I will draw the diagram as well so that you remember it for a longer time. Okay. So if they are asking the distance between these two, that will be lambda by 2. If they are asking the distance between these two, that would be lambda by 2. And if they are asking the distance between these two, that would be lambda by 4. Okay. Lambda by 2, lambda by 2, lambda by 4. Is that clear? Okay. So yeah, all these things will be used, whatever that we have studied in the past 2 hours or more than 2 hours, I guess. So whatever that we have studied in 2 hours, I will spend 30 minutes more and we will solve this question and then this question. So 2 questions we are going to solve. Okay. I can show you the question. This question you can try doing it on your own. Then you can try this question. This question completes here. You need to find the value of theta e and certainly gamma e as well. So once we are done with these 2 problems, then we will be done with the most typical concept of EM wave. I am telling you, not just EM wave. This is one of the most typical concept of your complete chapter. Not complete chapter, complete subject actually. Like in transmission line, it will also be used, and this is the topic where students get confused. But we have studied it very easily. First we saw the mathematics, then we saw what is 1 plus e to the power j theta. We studied about e to the power j theta, then we saw the standing wave pattern. Every single pattern we saw, every possible pattern we saw. Then we moved to our this particular concept, that is standing wave pattern in EM wave. Once we have seen that, then we are solving 2 problems which are like, let me tell you, if this question comes in the examination, only hardly 10 guys will get it correct. Hardly 10 guys in the complete question paper. I am saying, like in the complete like ECE paper will be written by 60,000 students, right? So in those 60,000 students, only 10 guys will get it correct. Conceptually, like तुक्का मार के तो सही हो सकता है, but conceptually मुश्किल से 10 लोगों का होगा. So these kind of questions are your rank deciding question. Like if you are preparing for a good rank, if you are preparing for like under 100 or under 50, then these kind of questions will decide the rank. Like under 50 guys as well will not solve this question in the examination. I am telling you, this concept is not even taught. A lot of teachers will not even teach this concept. Okay, so yeah, this is the thing. So very beautifully we are moving ahead in this chapter. So we will solve the problem, but let's take a break. I will take a break and then we will start solving the problem. Yeah, so let's solve these questions. So this is the first one, this is the second one. If you are not able to solve it on your own, then also it is fine. First we will solve this one, we will solve this question, then this question will be solved by you on your own. So once we are done with this problem and after that you are not able to solve the next question, then you need to worry. But if you are not able to solve this question, then also it is fine, because this is a like kind of new pattern for you. Okay, it is a new pattern. So how would we solve it? So this is a medium 1, this is a medium 2, a uniform plane wave incident normally on a dielectric wall. So this is the dielectric wall. This is a dielectric wall. So a plane wave was propagating here and then it was incident on this plane and then it would be reflected. So the total component of magnetic field is shown here. This is what they have written. The magnitude of total magnetic field in front of the pole is shown in the figure, right? So this would be your dielectric medium. This would be your dielectric medium where the wave will be transmitted. So here the wave will be incident and reflected, and here the wave will be transmitted. So the second medium is your dielectric medium. Dielectric medium. They did not talk about the first medium, so I will, by default, I will assume it free space. Okay, I should have written it actually. It should be written that uniform plane wave incident normally in free space on a dielectric pole. So it should be a free space. That should have been written in the examination. It would be written only. You need to find the epsilon r value for the medium 2. Also, you need to find the frequency of EM wave propagation. So looking at the diagram, first we will see what all things I can conclude. First, I can see that what will be this difference, lambda by 2. Do you agree to this point? This is a minima, this is a minima. What is the distance between two minima? Lambda by 2. So lambda by 2, this I can tell. Lambda by 2 is equals to 2. That I can tell. But forget about that. First, what I can see is that I can see the standing wave ratio. So magnetic standing wave ratio I can see, or it would be equals to electric standing wave ratio. That is equals to 1.5 divided by 0.5. 1.5 divided by 0.5. That is equals to 3. So 3 would be equals to 1 plus gamma E divided by 1 minus gamma E. Why I am doing the calculation with respect to electric field? Because I am more comfortable in that. I am more comfortable in the expression of electric field. We studied the complete standing wave ratio. We studied the complete standing wave pattern using electric field only. No? Here I was writing down the expression of electric field only. And for incident and reflection as well, first we calculate electric field only. So I am more comfortable in electric field. And they also know that you are more comfortable in electric field. That's why they will give you magnetic field. Okay. Your examination setter, your question paper setter also know that you are comfortable with electric field. That's why he will give you the pattern of magnetic field. But I know the relation between magnetic field and electric field. I am comfortable with electric field, but I know how would I solve if a magnetic field is given. Okay. So every time you would see in the examination, magnetic field will be given. So gamma E from here, if you solve it, 1 by 2 is coming. You can solve it. This is simple mathematics. Mode of gamma E is 1 by 2. This is 1 by 2. But what do you know? This is the magnitude. Gamma E actually is mode of gamma E to the power j theta I. So you are not sure about this angle now. So that angle you need to calculate. Why you need to calculate that angle? Because what I am going to do is that I know gamma E is equals to neta 2 minus neta 1 divided by neta 2 plus neta 1. What will be my neta 2? Neta 2 would be 120 pi under root mu r2 epsilon r2 minus what is my neta 1? 120 pi only divided by 120 pi under root mu r2 epsilon r2 plus 120 pi. So mu r2 epsilon r2, mu r2 is 1. Mu r2 is 1. Consider non-magnetic material. So mu r2 is 1. Mu r2 is 1. 120 pi I can take common. What I can do? I can take 120 pi common. So this everything will get cancelled. So what you are left with? 1 minus under root epsilon r2 divided by 1 plus under root epsilon r2. Are you getting this point? 1 minus under root epsilon r2 upon 1 plus under root epsilon r2. So from here I can calculate the value of epsilon r. So this is what I need to calculate. I need to calculate epsilon r2. So that I can calculate. But if I know the value of gamma E, I only know the magnitude. I do not know about this angle. So I only know the magnitude. So now I need to decide what will be this angle. So how I can decide that? That is the most important point. What do I see? At z equals to 0. At z equals to 0, I am having H maxima. What I am gonna write? Whatever the information that I can get from the question that I am writing, that's it. At z equals to 0, I am having H maxima. If you are having H maxima, that means certainly you would be having E minima. Say yes or no? So the conclusion is that at Z equals to 0, you are having E minima. E minima. Now can you write down your incident wave? Only the phasor form I am writing. That would have been e to the power minus E naught e to the power minus j beta z Ax cap. What would have been your reflected wave? That would be gamma E naught e to the power j beta z Ax cap. What will be the total? That would have been E naught e to the power minus j beta z 1 plus mod of gamma e to the power 2j e to the power j 2 beta z plus theta e. Say yes or no? Can you write it down this very carefully and very easily? These things can you write down directly without even writing down these expression? I could have written down this expression. How? Because I have the practice. You should also have the practice, like E naught e to the power minus j beta z, and then reflected wave will have gamma e. I'm not sure whether it will be positive or negative, but certainly it will have gamma e. And gamma e has some magnitude and the angle. So that magnitude is mode of gamma e and angle will be added here. So this analysis we have already seen. This analysis here we have already seen that whatever the angle is there, this was the question, this was the analysis, whatever the angle is there, that will be added. So you can keep in mind this factor, that is 2 beta z. This will be where it is 2 beta z plus theta e. Now if I need to calculate the maxima, 2 beta z, but I am not sure about maxima, I am sure about minima, that at z equals to 0 I am having minima. So if I need to calculate minima from here, so what I am going to put, that my 2 beta z plus theta e should be equals to what? If it has to be minima, that means it should give me minus 1 value, and minus 1 it will give me at 2n plus 1 pi. Is that clear to you? And at z equals to 0, you are having what? Minima. At z equals to 0, you are having minima. So put z equals to 0 here. If I put z equals to 0 here, 2 beta into 0 plus theta e is equals to 2n plus 1 pi. So from here this will be 0 only. So theta is coming out to be 2n plus 1 pi. That means theta e can take any value. What values it can take? Pi, 3 pi, 5 pi, all these values it can take. Is that clear to you? I wanted to find the value of theta e. So I thought that what I can do, I need to see maxima and minima. So at z equals to 0, I am having my minima. If I am having my minima at z equals to 0, E minima I am having. So where I will get minima? So this expression I can write down very easily. I will, like, this is not tough. I can write down the incident wave, I can write down the reflected wave. Reflected wave just have this gamma e here, and this will be changed from minus to plus it will have. Then if I combine both of them and take this outward common, if I take this as common, so what I am left with? In between I am left with this expression. Which expression? This expression. And if I need minima, that means I need to keep this as 2n plus 1 pi. Do I need to mug up anything, or can I keep this expression in my mind? That certainly it would become 2 beta z. How it would become 2 beta z? Because e to the power minus j beta z, e to the power plus j beta z. So if I take e to the power minus 2 beta z outward, so 2 beta z it would become, and plus theta e. Why theta e? Because your gamma e will also have some angle. So if I have enough practice, so I would ignore all these steps directly. I would be writing this step in the examination if I have enough practice, because this step I have already written here, where I have written when we were doing the analysis, that for minima I need this. So if I have enough practice, I am not asking you to mug it up. Okay, any day you can write down these two expressions and you will be getting this final answer. Which two expression? These two expressions. Any day you can write down these two expressions. Like very easily you can write down. So you will reach there anyhow. But if I have enough practice, I can write down this thing very easily. Like directly I can write down this particular line. If I don't need to mug up, if I do not want to mug up, then I can write down these two expressions in the examination itself. How I will write down? That is very easy, that I have already taught. Incident, reflected, both combined, then take one outward, 1 plus this expression, then I just need to maximize this. When it will be maximized, it will be, sorry, I need to minimize now, because at z equals to 0 I am having minima, so I need to minimize now. When it will be minimized? 2n plus 1 pi. So theta e is your pi, 3 pi, 5 pi, all these values. So what you are getting as gamma e now? Gamma is your mode of gamma e to the power j theta e. What is your mode of gamma e? 1 by 2. Mode of gamma E is 1 by 2. 1 by 2 e to the power j pi. I can take any angle, pi, 3 pi, 5 pi, any angle I can take. All will give me same answer, because what is e to the power j pi? If you know it, it is -1, right? E to the power j pi would be equals to cos pi plus iota sin pi. What is sin pi? 0. What is cos pi? -1. And that is very obvious. Why that is very obvious? Because I want this angle, I want this value to be, when I want this value to be -1, when I want this value to be -1, at that time I keep it equals to 2n plus 1 pi. So certainly it has to be -1 only, or you can calculate directly. Forget about it, don't think this much, okay? You will not be able to think this much in the examination. So just calculate. E to the power pi is -1. E to the power 3 pi also, that is also -1. E to the power 5 pi is also -1. So that is -1. That means your gamma E is -1 by 2. So your gamma E is -1 by 2. So your gamma E is -1 by 2. Now I have to add a page. So gamma E is becoming -1 by 2, which is equals to -1 by 1 minus this divided by 1 plus under root this. Okay. So can I solve it? Certainly I can solve it. What I will get? If I put 1 by 4, no, if I put 4, so 3, 2, no, let's solve it only. So we will solve it only. So -1 minus under root epsilon R2, 2 minus 2 epsilon R2. Epsilon R2 is equals to 3. So epsilon R2 is equals to 9. This I am getting as 9. So 1 minus 3 is -2 and 1 plus 3 is 4, -1 by 2. Yeah. So epsilon R2 is equals to 9. This is the correct answer. Okay. What else I needed to find? I needed to find wave propagation frequency. So lambda by 2 is equals to 2 meter. What do I know? Lambda by 2 is equals to 2 meter. So lambda is equals to 4 meter. Okay. So lambda I know. What is lambda? 2 pi by beta. Lambda is 2 pi by beta. So what is the value of beta? Beta is pi by 2. Okay. What is beta? Beta is pi by 2. And omega I need to find. Omega by c. And then under root epsilon r. But under root epsilon r, yeah. You tell me one thing. This is the beta of medium 1. Beta of medium 1, right? Medium 1. This is lambda 1, beta 1, beta 1. Why is that so? Because we are calculating all these things here. So this is the lambda of medium 1. Very important point. This would be your, I should have written lambda 1 by 2. Okay. So lambda is equals to 4 meter. What do I know? Beta equals to 2 pi by lambda. So from there, can I calculate beta? Yes. Beta will be beta equals to 2 pi by lambda, or lambda equals to 2 pi by beta, whatever that you know. So can I calculate lambda from here? 2 pi by beta. Lambda is equals to 2 pi by beta. From here, what is the value of beta I am getting? Pi by 2. So what is the value of beta? Omega by c. Omega by c under root epsilon r. Will I keep 9 here? No, I will keep 1, because that is for free space. Are you getting this point? Here I will keep 1. That is equals to pi by 2. So omega divided by 3 into under root, this calculation I am doing here. Okay. Under root 1 is equals to pi by 2. 2 pi f pi by 2, 3 by 4, f is equals to 0.75 into 10 to the power 8 hertz. Is that correct? Pi and pi get cancelled. 3 goes here by 2, 3 by 4 into 10 to the power 8. So 0.75 10 to the power 8 hertz. That is the answer. Are you getting this point? What is the important point here? That this is lambda 1 by 2 for medium 1. This lambda you are getting for medium 1. All the calculation you are doing in medium 1 only. There is no use of medium 2. Only we can find out the epsilon R2 by how? By calculating the value of eta. and eta I can get from gamma E. So for gamma E, first I need to see the standing wave ratio. From there I got the value of gamma E, but I got the magnitude. If I need to know the angle, then I need to think. So if I need to know the angle, then I need to think in the maxima and minima. So what I know that at z equals to 0 I am having minima. If I am having minima of electric field, then what do I need to do? 2 beta z plus theta e is equals to 2n plus 1 pi, and z equals to 0 if I put there, from there I got the value of theta e, that is coming out to be pi. So from there gamma is equals to minus 1 by 2. If I have the value of gamma e, then I can calculate epsilon r2. But if I need to calculate the frequency of wave propagation, so for that lambda 1 by 2 I am having the value, that is equals to 4 meter. So from there beta 1 is coming out to be pi by 2. Now that is equals to omega by c under root epsilon r1, but epsilon r value is 1, not 9. Why is that so? Because we are calculating it for medium 1. So that is your 0.75 into 10 to the power 8 hertz. Now tell me one thing, if they had asked this question that you need to find the frequency of EM wave propagation for medium 2, then what would be the answer? You need to find, here did they write medium 1 or medium 2? In the question they are asking find the frequency of EM wave propagation. Did they mention you need to find it for medium 1 or medium 2? No, they did not mention. Why they did not mention? Because frequency of propagation never changes. Do you remember this thing? I wrote it down as a note. Highlighted it. I highlighted it when we were studying the previous chapter. In the when we were studying the previous lecture. In the previous lecture, what did I say? Omega never changes. Omega never changes. Okay. So this you need to keep in mind that omega, the frequency of EM wave propagation here and here will be same. But since we are calculating in this region, this lambda 1 by 2 is equals to 2 meter. Lambda 2 by 2 is something else that I don't know. I just know that lambda 1 by 2 is equals to 2 meter. Lambda 2 by 2 could be something else that I am not sure. What is that? I am not sure about that. Are you getting this point? If they had asked you to calculate the lambda 2, how you would have calculated? For lambda 2, I would require 2 pi by beta 2. Can I calculate beta 2? Yes. Beta 2 would be omega by c under root epsilon r2. Do I know the value of omega? Yes. Do I know the value of c? Yes. Do I know the value of epsilon r2? Yes. I will get the beta 2. From there I can get the value of lambda 2. Okay. If they had asked me the wavelength of medium 2, wavelength of EM wave in medium 2, then I could have calculated that value as well. So here the point was this would be lambda 1 by 2, not lambda 2 by 2. Okay. Because we are calculating all the things in medium 1. So that was a good point. And omega never changes. So for the medium 2 as well, there will be same omega. Frequency of EM wave propagation never changes, be it in medium 1 or in medium 2. Is that clear? Let's move to the next one. Try solving it on your own. This is the half question. What you need to find? You need to find the reflection coefficient. Okay. So try finding the reflection coefficient. First, what I am going to calculate? I am having my ESWR is equals to what? 3. Or you can say 1.5 divided by 0.5, that is equals to 3. And from here, can I calculate my gamma E? That is equals to 1 by 2. Mode of gamma E is equals to 1 by 2. This calculation we have already done, right? Here, what is my maxima? This is my maxima. And what is my minima? This is my minima. If I calculate the ratio, then I am getting gamma E is equals to 1 by 2. Okay. But your gamma E is mode of gamma E. Along with that, it will have some angle as well. So that angle I need to find. How would I find that angle? How would I find that angle? So at lambda by 12, at z equals to lambda by 12, what you are having? H minima. That means you are having E maxima, right? So at z equals to lambda by 2, you are having E maxima. And how would you calculate E maxima? Because what will be your total electric field? And if I only talk about magnitude, so E naught 1 plus mode of gamma E to the power j 2 beta z plus theta E, right? So now I need 2 beta z. For maxima, what do I need? For maxima, what do I need? That 2 beta z plus theta E should be equals to what? 2n pi, right? Here I needed minima. Here I needed minima. So I put it equals to 2n plus 1 pi. So here I will put equals to 2n pi. So no need to mug up anything. Now 4 pi by lambda. What value I will put here? Lambda by 12. Why not minus lambda by 12? Look, what did I say? That z value, our final answer will always come positive. Did you remember 0, lambda by 2, 2 lambda or whatever, lambda by 4, all these were becoming positive only, no? In the graph, it is being shown by negative value. That doesn't mean you will put negative here. No, you will put positive only here. If it was propagating in minus z direction, that's why we put minus lambda by 12 here, there. So here you will put positive only. Plus theta is equals to 2n pi. So from here what I am getting? Pi by 3 plus theta is equals to 2n pi. So what is my theta e? 2n pi minus pi by 3. So which value I will pick? Any value I can pick. N equals to 0 if I put. N equals to 0 if I put. What I am getting? Theta is equals to minus pi by 3. There you go. This is the answer. This is one of my answer. And this is the other answer. So any of the answer you can pick. Like let's just say this answer is not even in the option. Then what would be your answer? 2 pi minus pi by 3. This could be your answer. Or 4 pi minus pi by 3. Anything could be your answer, right? Any of the possible answer are there. Are you getting this point? Whatever that is available in the option, that we will pick, right? So yeah, that's the answer. This is your angle and this is your magnitude. That's the end of this lecture. I hope you must have understood every aspect of the standing wave, and this will be highly used in transmission line. That's why we have spent a lot of time here. And if you found it helpful, please do share it with your friends that what kind of content is being taught here and what kind of clarity you are getting, so that you can share with your friends. Also, you can comment down how did you find this lecture. Now we will move to the EM wave propagation in arbitrary direction, or you can say in a general medium or in a general way. That wave will be propagating in a general way. So that basic trailer of that particular concept we have already seen, where we have seen EM wave in a random direction. That means E naught cos omega t minus 3x minus 4y. Have we seen anything like that? Yes, in the assignment. There I asked you to calculate the value of beta. Do you remember? How did you calculate the value of beta? 3 square plus 4 square. So this concept only we are going to see in more depth. So that will be our next lecture. There we are going to see EM wave will be propagating in a general direction, any general direction. Till now it was propagating in AZ cap or in AY cap or in AX cap. Now it will propagate in AX cap plus AY cap divided by under root 2. In this direction it will propagate. Is that clear to you? Okay. So that we are going to see in the next lecture. That will be also very interesting. In the next lecture, what will be important? Only the calculation part will be important. So there no need to focus much on concept. Here we need to focus much on concept. That's why we focused a lot on concept and then we saw the questions. Okay. Thank you very much. I hope you enjoyed the lecture.